Let us continue with our module 6 over here, and in the module 6 we are going to learn about the classes and objects, abstract class, and the interface, as well as the OOP or the object oriented programming. So basically we'll be covering the object oriented programming principles, right, from the very beginning. So let us get started over here. Before we start this video, a small and a humble request from my side. Only a small percentage of people watching this video are actually subscribed to my channel. So if you like this kind of content that I'm creating, please make sure to hit the subscribe button or join my community over here. It really helps my channel and me to grow, and it also encourages me to create more content for my YouTube channel. Now let's go to the module 6 over here, and let me just go and create our new file first of all, right? And let me add the readme file over here, and I have added this particular readme.file. And let's go to the introduction over here, and over here we can see that the OOP or the object oriented programming is a programming paradigm based on the concept of an object, which can contain our data, or we can also call it the attributes or the properties over here, and a code which can be of the methods, or we can call it also as a behaviors over here. And OOP or the object oriented programming aims to make the software development more modular, reusable, as well as the maintainable. And Dart is a fully object oriented programming language, meaning everything in Dart is object, and even numbers, function, as well as the null types all are has the root of the object over here. And some of the core concept over here, right? So the first one is the object. An instance of the class represent real world entities like car, right? Content state, which is of the data, and a behavior that can be of the methods over here. And the classes over here, it's basically a blueprint for creating an object. So whenever you want to create an object, we create the class, right? Class basically is a blueprint for your object that you are going to create. Define the properties and then the methods. So in the class we have to define the properties and methods over here. And the next concept is the encapsulation. This is one of the pillar in the OOP or the object oriented programming, right? So the first one we are going to see is the encapsulation, which is bundling the data and methods, protecting data integrity, restricting access to components. And the next one will be the inheritance, which is the code reuse mechanism, and the parent and child relationship, promote hierarchical structures, as well as the polymorphism over here. The object takes a multiple form, flexibility in the design, runtime method selection, and also the abstraction, the final OOP principle, the abstraction, hide implementation detail, so essential feature only, focus on what, not how. So basically these are the OOP principles that we will be covering, and make sure to go and read this particular file and the official documentation as well. And some of the benefits of using the OOP is of the modularity, right, reusability, maintainability, flexibility, as well as the security over here. So let's go to the classes and objects over here. A class is a fundamental building block of OOP in Dart, right? And it's a blueprint that defines the structure and behavior of any object. An object is an instance of the class. An object is an instance of the class, right? Created based on the blueprint. So we'll go and see practically how we can create a class and how we can create an object from that particular class as well. And let's go over here, defining a class. And the class are defined using the class keyword, right? We have to use a class keyword followed by the class name, right? Conventionally it should be on the Pascal case, right? The uppercase, and then any other the word should also start with the uppercase. So make sure you follow this particular Pascal case for naming convention. The class body contain instance variable, right, which is also as a properties, we call as the properties as well. The instance variables, we call it as a property, and instance methods, which we call it as a behavior. So the class can have properties as well as the behavior. So if I say a behavior of the class, that's the methods, and if I say sometimes the properties of the class, that's the instance variable of the class. So I may use it interchangeably over here as well, right? And how we are going to create an object right? So objects are created using a new keyword, but it's optional from the dot to. Previously we had to make use of a new keyword, but we don't have to use any new keyword. And followed by the class name and parentheses for the constructor, right? And each object has its own unique set of instance variable values. So I would like you to go and read all of this documentation, and let's try to go and start practically by creating and understanding how to create a class and how to create an object and all of this stuff. So let's go back to our classes and the objects file over here. Let's try to create our first class over here. So as we saw in the documentation, we have to make use of the class keyword over here and a name of the particularly the class. So let's say we will give our name as the dog over here, right? The OG dog over here. So here now we have a class. This is a class. So we have to make use of the keyword class as well as the given name for our class. So this is a dog class. And now let's go and have some of the inside the class. What we saw is we can have the properties, right, as well as we can have the behavior, or the we can have the instance variable or the method. So let's create the instance variable over here, and I can just go and have the instance variables, and also we'll call this one as the properties as well, right? And just for the documentation purpose, so let's have the instance variable of the type each of the string, and we'll have the name as well as we'll have the string, and then let's have a breed, right? So the breed over here. Let a dog can have a name as well as the type of that, the dog breed, and it can also have the age, right? So based on a real object. So dog is a real object, right? So we can link it to a real object, what we saw in the documentation. And once we have this particular the instance variable, we can go and create the class constructor. So let's have the class constructor over here in the OG top, and let's construct our class. And once we construct the class, there is a non-nullable instance variable. So what we have to do is we have to go and initialize. If you see the error, it's already giving us that particular error. So what I have to say is this dot the what we have the name, as well as we have this dot the breed, as well as we have to assign this dot the age over here. So basically the constructor is taking all of this and initializing all of this variable, right? And now once we have the later we'll discuss more about the constructor. Let's add some doc over here, constructor over here. So let's have some okay, so let's go and we'll add the behavior, right, or the methods, or we'll call, okay, so let's call this one as the methods as well as the behavior, right? BHAVI or behavior. And in the behavior or the method, what we can say is we know already how we can create a function. So the difference between the function and the method over here is once we create a function inside the class, we call it as a method, and if we create it outside of the class, then we call it as a function, right? So that's the difference over here, just remember. So the dog can bark over here. So now we have one, this is actually a function. If you just go and put it outside of this one, right, outside of the class, we'll call this one as a function, but once we put it inside the class, we are going to call it as a method. So that's the how we basically say it. So methods inside the class, and outside the class we call it as a function. So once we have the bark, we are going to say that I'm just going to print out something like the my name is let's just go and have the name over here, and I'll just go and say hoof and hoof, right? So let's just go and say that one over here. So this is what we are going to print over here. Now this is a behavior, and also let's just go and have the another one, right? So let's just go and arrange this one, and let me just go, okay, so let's just go and have the another we already have discussed about the void and all of this stuff once we learned about the methods, or sorry, the functions, right? So here I'm going to say the let's say a fetch, and with this particular fetch I'm going to pass in the arguments over here, right? Let's just go and pass in the method parameter basically, right? So let's just go and say the string, and I'm going to pass in the item, and I'm just going to go and copy that and paste it over here, and my name is dash foo foo foo, and I'm just going to say my name is 222, and I'm going to fetch the dollar sign, fetch our item whatever we are passing in, and finally we'll add the one more, which is of the void, and display info, and here we are going to display all of the information about this particular object. That will be of the name, will be of the name, right? And then we also have the breed, will be of the type is of the breed that we have, and for also we have the age as well. So finally let's just go and save the age over here, and that's how we are going to create our first class over here. The keyword, using a keyword of the class and giving a name, and once we give a name to that particular class, in this case we are giving a dog, and inside the curly braces over here we are going to define our properties as well as the behavior over here. So the properties are the instance variable basically, right? So these are the instance variable, and these are the behavior or the methods over here. And I also mentioned that the methods are basically inside the class, and if it's outside of the class we call it as a function. So how we are going to make use of this particular class is, let's just go down over here, and I'm going to create my entry point for our application, and that will be of the void the let's say main over here, and here we are going to create the dog type, which will be of the my dog one, and I'm going to define the dog over here. And if you take a look at the constructor over here, we have to pass in this particular fields, right? So let's just go and say the name of the dog is of the Max, breed something maybe of, let's just go and have a breed and 2, right? And now if I go and I can just go and execute all of my methods from here dot, and I get the access to the instance variable, right? Because this is an instance variable, so I can just make use of the dot notation and access all of the instance variables as well as the methods that we have defined, right? And the hash code, runtime, type, and all of those, the extra methods, and then the are basically coming from by default, right? So once it's actually going to it's actually coming from the default object or the parent object of this particular class, right? And let's just go over here and let's access our age over here, as well as the my dog, and then the name, as well as the finally we are going to go and access the my dog dot the what we have is the breed over here. And we can also go and call all of our methods over here, and that will be of the bark, and then the my dog dot we are going to call the fetch, as well as the item we are going to pass in the item as well, and then the my dog over here dot the we are going to call the display info over here. Now let's just try to go and run this one. Let's try to execute this one. Now you can see that my name is Max, my name is Max, paste the item, and then the Max, breed, as well as the age over here that we are displaying. So we saw that about the object. So object is basically the instance of the class that represents a real world entity, right? It contains the data, behavior, which are the method. So if I go and see, let's just go and see the creating an object over here. Then object are created using the new keyword, which is optional from the dart2x, right? And followed by the class name and then a parenthesis for the constructor. So that is what we are doing. So this is my object, this is my class, and this is my object. So once we go and instantiate our class, all right, so this is the instantiation of our class. So to go and once we are saying go and instantiate that particular class or create the instance of that particular class, that means we are creating an object out of that particular class. So you need to remember that. So how the object is created? Objects are created from based on the class, right? So we have to instantiate, or we need to create an instance of that particular class in order to get create our objects. Once we instantiate that particular class using this parenthesis, sometimes you may have these and sometimes you may not have, right? So if you are not passing any of the arguments to the constructor or parent, then you just have to remove that and just go and instantiate our class over here, and that's going to create our object out of it, right? And once we have the object, we can go and access all of the properties as well as the behaviors that we have defined, or the default behavior or the properties that it inherited, right, from the object. So let me just go and add this some documentation for you guys to understand. This is to create an object instance of a dog class over here. And the next one is to access our instance variable over here. So let's just go and say this is accessing the instance variable using the dot notation. So from the object dot, and using that particular dot notation, we can access the instance variable, as well as using the not notation, we can just go and call all of the methods that we have for the behavior, call the instance method using the dot notation. Why we call it as an instance variable and then the instance method issue? Because we have to first create an instance and then we can access it. Without creating the instance of the dog class, or without creating the object of the dog class, we cannot go and access that particular properties as well as the behavior. So that's why we call it as an instance variable as well as the instance method, right? So I hope you got the idea of it. And the next we are going to learn about the constructors in the our class. So let's just go and create the new file first of all, and let's just call this one as a constructors.dot, and let's go back to the documentation or the readme file over here, and let's try to understand over here. Constructor are special method in our class responsible for creating and initializing our new object or the instance of the class that provides several types of the constructor to handle a different initialization scenarios. And like the other programming language, like the Java, considering a Java, you can have a multiple constructor, right? So here in the dot, we can also create a different kind of the constructor to handle a different scenarios of the initialization of our object. So constructor is a special method, remember that, in a class responsible for creating and initializing the new object or the instance. So once we want to create an object of that particular class, it is the constructor that we are going to call, right? So this is a constructor method. And then we have a default constructor. If you don't declare any constructor for a class, that automatically provides a default or the unnamed no argument constructor. This constructor calls the no argument constructor in the superclass, right? So let's try to see the next one, which is of the generative constructor. These are most common type of constructor. They create a new instance of a class, right? Unnamed constructor, the primary constructor, often used for simple initialization. Name constructor allows you to create a multiple constructor for a class, each with a different name. And this is useful when you want to provide a different way of creating an object. Maybe you want to have a different name for that particular constructor, and here's a different one, right? And let's see the another one which also has the factory constructor over here. So the factory constructor is to mark with a factory keyword. Unlike a generative constructor, a factory constructor does not necessarily create a new instance of its class, right? So it's not necessary that the factory constructor is going to create a new instance of our class. It can return an existing instance, right, like a singleton, and for a catch from a catch, right, and returns an instance of a subclass. And it can also return an instance of a subclass or perform a complex initialization logic as well. So this is the use case of the factory constructor. It's not necessary that it's going to always create a new instance. So if you have some requirement like creating a singleton, right, inside a single instance of the class, and by checking like if the class is already initialized, then you want to just return a previous instance, and all of this stuff can be done using a factory constructor, right? And next is the const constructor, and marked with the const keyword, used to create a compile time const object. So if you want to create a compile time const object, then you have to use a const keyword in your constructor. This means that the object state is fully determined at the compile time and cannot be changed. So we have already learned about the const keyword and how to use it. What's the difference with the const and the final? We have already learned that. And all the instance variable must be also a final, right? So with the const constructor, you have to make sure that all your instance variable is a final one, right? And if a class has a const constructor, you can you can create a constant instance using the const class name that can lead to performance benefit, as the Dart can reuse identical constants object over here. So that's going to improve some of the performance, but later we are going to see all of this, how we are going to do it practical. So let's move on to creating that practically over here in the constructor over here. So let's just go and create the class over here, and I'll just go and call this one as the point over here, right? So let's create a simple class of the point over here, and with this particular point, let's just go and first of all go and create the constructor, right? So let's just go have a class without any constructor, and I'm going to go and have the void the main method over here just to go and initialize our object. So I'm going to say the not the class, so I'll just go and say the point over here, the type of the point over here, point, and the p1 I'll just go and call this one, and then I'm going to initialize the point over here, right? And now I can just go and call the p1 and use the dot notation, p1 dot, and it has the hash code and runtime. This that are the default. It's going to return the type. It has a return type int. It has a runtime. It has a return type of the type to a string and all of those functions, because we haven't defined anything over here, right? So let's just go and try to go and run this one. So it runs successfully without any of the error. So why is that? Because even we haven't provided any of our constructor, there is always a default constructor executed once we go and instantiate our class over here and create an object out of it. The default constructor is always going to be called from the superclass or the parent class, which is an object of this one, right? And now let's just go and add some of the instance variable that will be of, let's add the final one, and then the type will be of the double, and I'll just go and say the x, and also the final which will be the double, and then the y, x and y, two variables we are going to take. And let's create our default one without a named constructor. So this is a default constructor, and once we have the instance variable, we need to initialize in our constructor. So this dot, and I will also have to say this dot the this dot the y over here as well, right? So now we have the constructor, and now we have the constructor. We have to pass in these two positional the arguments that we have defined. And let's say if you want to go and define a final value directly over here, and which is of the 20 over here, and let's just go and remove this one from here. So you can also do that if you want to initialize the default value over here, but most of the cases is once we have the instance variable, we are going to pass it through the constructor, right? So that's how we are basically using in our day-to-day programming or day-to-day coding. So here I need to go and pass the x and y. Let's just go and say 10 and the 20 over here. So we are going to pass that one, right? So this is the default constructor that we have defined, and this is the, if you go back over here, and if you go and let's just go to the constructor over here, constructor, the default constructor, and this is the generative constructor that we have defined, right? And this is the unnamed constructor. There are mainly two most common type of the constructor, which is the unnamed constructor as well as the named constructor. And there is also the default one, right? So the Dart automatically provides a default unnamed no argument constructor, right? This constructor calls the non-argument constructor in the superclass, which is an object, right? Object is also every class that we create is going to inherit from the superclass, right? Superclass, that's the object class. And once we have done this one, so let's just go and create the let's have the comment over here, the comments, and let's add this is the type of the, let me just go and add the comment over here, and then comment will be to a named generative constructor. Default is no other is defined, or the explicit here. So we have explicitly defined our generative unnamed constructor. Next, we are going to define a named constructor. So let's try to go below here, and let's add the comment generate constructor, named constructor. So the first thing is the class that we have, which is of the point, point dot, and then I have to give a name of that particular constructor. So origin. So this is the name that I'm going to provide for this particular class. And now what I need is to initialize this variable as well over here. So how I can do that is I can just go into the column, and the x that we have defined will be of equals to the default one. I want to define a default one, and dot the 0.0, and also I have the y which is of equals to which is of equals to the 0.0 or default value over here. Now if I go down over here and if I just go and create the point point, right? So I'll just go and say p2, which will be of equals to the point dot the origin over here. And now you can see that if you want to pass the constructor value, then we can use this one. But if you want to go and call the constructor without going and passing the constructor the parameter over here, or without passing any arguments to that particular constructor, then we can go and see, we can make use of this particular constructor. So this is also giving us the same. So if I go and set the point 2, and if you need the dot notation, you can access the x and y as well. Only the value that we have set is the default one, because we have defined a default one over here. And if I go and access that, I can go and easily access. It's the same thing from the p1 as well. So we have the access to that one, but the thing that we are doing here is we are passing it through the constructor. And here in some cases you may not want to pass it and you want to have a default value, then you can obviously go and set in this way by creating a named constructor over here, right? So this name can be anything. Only thing is that you have to provide a class name in front and use the dot notation over here. And let me just go and add the, let's just go and create the body, and let's just go and add the print statement over here. As well as what you can also do over here is you can also copy this from here, and let me just go and provide it over here, and I can just go and remove from here as well. So if I want to remove it from here, I can just go and assign a default value after this particular colon over here, right? So this is how I can do, and I can just go and have the default constructor over here. And okay, so I got some errors. So this code instance class over here. Okay, so that's because I need to remove this one, and let's just go and have, okay, so I can just go and copy this one from here, and let's just go and print out over here. This is the named or the unnamed constructor. So this is of the unnamed constructor that we are going to provide it over here. So we can do the same way, and we have to remove that from here as well. So it's depend on how we want to actually go and initialize. So if you want to pass it from here, or you can set it as a default one, or you can also create a named parameter and provide that. And let's just go and copy this one from here, and let's add another scenario. So let's say if you want to pass in a list of the x and y, right? So instead of passing a single value, let's say we want to pass in a list over here. So let's say we have the type is of the list, and it will be of the double. So list of the double that you want to pass in. Let's say we want to say the let's say a data over here, and here I don't want to provide this, right? Or let's say I want to set that one as well. So here in the x I want to just go and set it the value from our data that we are receiving, data dot the first value from here. So let's say a 0 index, and then the y will be of equals to the data, and then the second index over here. And how I'm going to pass that one, this is originally, so let's say from list, if I want to say from list, from JSON, you can have a lot of those stuff, right? So once you are creating actually a Flutter application, there we are going to use a lot of the from list, from JSON, from map, and all of those, the named constructor, right? So this is the named constructor, and we are passing in the list of the data over here. Now if I go and create that, so let's say I'll just go and say the final p3 over here, right? This is a auto type inference. We have already learned this one. We don't have to actually go and mention the strictly the type over here, but we can just go and provide our point from the list, and it's going to auto type info, which is the type is of the point. We have learned that one already. And in the list, I'm going to provide the some value over here, comma, and then let's provide another coordinate of 12.358.6 over here. And now the same thing that's going to be executed point. And then I can just go and okay, so let's just go and say the x, right? And now if I go and run this one, you should see that the unnamed constructor is coming from here, right? The default value is always 0 and 1, and the named constructor, which is of the dot origin, which also has that particular value. And then finally we have the named constructor, and this is not the origin. Okay, so named constructor, this origin, so unnamed constructor, the default one, right? So this is default one, and this is of the from list over here. So let's just go and run that one. We'll see that this is from list, this is from origin, and this is from the unnamed, the point over here. And the next one, we are going to create the another constructor which will be of the factory constructor. So for the factory constructor, we have to use the factory keyword, so FSE factory, right? The factory keyword over here, and that will be of the class name as well as the named constructor. So that will be let's say a catch over here, CSCH. Okay, so let's say a catch over here, and here we are going to take the double of the x and then the double as well as the y over here. So now we have this particular named constructor, the named catch constructor with the factory constructor over here. And once we have this one, what I can do over here, from here we need to return it. The body might complete be a normal, causing null to be returned. So here we have to return actually. So this one, CSCHE the catch, CSCHE the catch over here, it's going to return, right? So the factory constructor always returns the same existing instance or the instance of the subclass. So it has to return some either one, existing instance or the instance of the subclass. So let's try to go and let me try to go and add one variable over here. So let's say we have the static variable over here, static final, and that will be of the type will be of the map, and here we are going to provide the string. So let's say string string, and then the another one will be type is of the point, the key, and then the value. So the key will be of the type is of the string, and then the value will be of the point itself or the point class over here. And let's say the CSCH catch for this one, and the default one I'm just going to say the empty map over here. And once we have that, let's try to go and check. Let's create a final variable of the key, and then the key will be of equals to something like the string, right? So let's go and create a string value, and I can just go and say something like the $x, and then the comma the $y. So just a simple key that we need to check. And once we have the key, let's go and have a condition. If the underscore the catch that we have, which is the type is of the map, and in this we are going to contain the key. So we want to check if this particular key already exists over here in our catch, and in that case, if it is the one, then I'm going to print something from here and returning. So we are returning the catch version of the catch, we are version of the point, so we are returning that one, right? For as well as the we have the $sign x and y, right? So x as well as the x, and then we also have the y over here. We are returning this one from the catch version. So what we have to do is we have to return from here. So return our underscore the catch and then the key that we have provided. So key that we have to provide over here. Let's just go and close this one. Okay, so it's a nullable type, so maybe let's just go and say the not null over here. I'll just use a bang, but it's not a good practice to have that, but for now let's just go and use it over here. So if the catch in the catch over here, in the catch variable, if it contains the key, whatever value we are passing in over here, right? So if let's say if you pass in 0 and 0, and then we are setting the key for that one, and in the next one, if we again pass in the 0 and 0, the key will be same. And if that key is already present in our catch, then what we are going to do is we are going to return that particular we are going to return the same object over here, which is the point, instead of creating a new one, right? So in the else part, what we want to do over here in the, let's just go and say in the else part over here, in the else part we are going to create now, if it is not in the catch, we want to create a new object of that one. So let's just go and set the new point over here, and this will be of the point that we have. And in the point we are going to, okay, so here we are not passing any value, so let's just go and pass in some value over here. So default one be always a 0, so we don't want to do that one. Let's just go and remove that case, and here I'll just go and make use of the this dot the x as well as the this dot the this dot the y over here. So we have to pass, right? So here we are going to pass in the x comma y that we have defined, and now I also have to pass in, let's say 20.20.10.20 dot comma, let's say 12.20, and then now we have that new point over here. Now we can just go and print out this one from here. Let's just go and close this one. Once we create a new one, returning a new version of the point for x and y, right? And also we have to create the catch as well. So once we have this, we have to add that particular to the catch. So let's say the catch key that we have defined, and then the value will be of equals to the new point that we have defined, right? So key should be of the string, and then the value should be of the point. That is what we have defined over here. And let's say we want to go and print out something for this one as a print, creating and catching a new point for x and y, right? So this is what we have set up over here, returning a new version. Okay, so now this one, let's just go and move it to the up over here, right? Let's just go and format this one, and then we are going to return from here. Finally, we also have to return, right? So when return our new point that we have defined, let's just go and close this one over here. And now once we have all of this, let's just go back over here, and now let's try to make use of the catch that we have defined. So let's say final, I'll say that is a pre4 now, and the point that we have, point dot from point dot the catch, right? So here we are going to say let's go and say the 20.20, and then we also have some value like the 21.360, and let's try to go and okay, so let's try to go and execute this one first of all, creating a new catch, creating a new catch point, creating and catching a new point for this one. And if I go and run this one, creating and catching a new point, so actually we are creating that particular instance every time over here. So I guess let's just go and comment out all of this for now, just for testing. Let me just go and comment out all of this over here, and let's try to run this one over here. And okay, so returning a new version of the point and creating the catch, and then returning a new version of the point, as well as is creating a new catch as well. Okay, so let's go and create the another one. So let's just go over here, let's create a tree. So here p4, p5, and this will be of the p6 over here, and let's just go and add this one, a different one. So let's say 10, and this will be of the 30 over here, or the 30, and let's try to go and print our catch over here. So let's just go and catch CHE, the catched version of our dollar. What we have is a p4. This is a p4 that we have, right? And let's try to go and duplicate this one, which is of the p5, and as well as the p6 over here. Let's try to run this one more time, and now you should see the catch one over here actually. So returning a new one, creating the catch, returning a new one, and then creating a catch, returning a catch one over here. Now you can see that the catch version of this one is actually going to return, because we have passed in the same value 2 times, and this is actually a key for our map over here. A simple example over here, right? And this particular factory constructor, right, it can return. So let me just go and add some documentation over here for you to understand. Let's just go and add it below over here. A factory constructor, this is a factory constructor, and can return our existing instance or the instance of the subclass. So currently we are returning the instance of the same class over here, not the subclass over here. And it's really useful if you want to go and check some condition, run some logic, complex logic, and return a subtype based on that particular condition, or return the catch version, like creating a single instance, and all of this stuff over here can be done using this one. And the next one, let's just go and add the constructor over here. So let's just go and say the const, and then the point and then we have to have a name conversion. So let's say s1 and the constants over here, and let's pass in the this dot the x and then this dot the y as well over here. Let's just go and close it. Now we have the constructor over here. So let me just go and add some documentation for this one as well. Let's add this is the constructor over here, right? And the all instance variable must be a final one over here. So that's why we have defined a final one. So if you go and remove that, that's going to give us an error because that's not the final one. So all the instance variable must be of the final one if you want to make use of the constructor over here. So let's try to go and execute this one over here below here. So let's just go and let me just go and comment out this one for time being, and let's go down over here and let's create the const one. So let's say const, and then the p, what we have is 6, and let's say p7 over here, right? And this is equal to the point that we have, point that the const. So let's just go and add the const, and x maybe a 10.20 comma, we have something like the 30.21 over here, and let's just go and close this one over here, and let's just go and print out over here, and that will be of the const, let's just go and as the const of our p7 is that, and let's just go and print out the const and as the another const, it will be of the p7 over here. Let's just go and close that one, and if I go and run this one, we are going to get that the const of the point over here, right? So const of the const p7 instance of the point, and if I just go and create the another one over here as well, sorry, let's just go and add the another one, and this will have the p8 over here, and p8, and let's try to pass in the same one over here, and let's just go and say this is of the p8 over here, and I'm going to check this one as a p8 as well, and let's try to run this one. We have the instance of the p7 and then the p8 for the point itself over here. Now let's try to see what's the good point about using the const over here, by checking if the if these consts are identical in the memory as well, right? So if it is reusing this particular object over here. So let's just go and print out something over here, print print over here, and I'm going to say the p7, right, and then the p8 that we have are identical over here, and I just can just go and make use of the string interpolation identical over here, print the object to the console, right? So let's just go and add the identical a and b. So we have the p which is of the p7 and then p8 over here. This is identical. So let's just go and run this one, and you will see that it is true, which basically means that once we create the const one, if this has the same the const value, it's going to reuse that, right? So if this will be really helpful in the memory consumption, right, memory management in your application. So using a const is always a good practice over here if you want to reuse that, right? So let the dot manage that, and let's not go and create a multiple instance once it has the same requirement, right? The requirement is of the same one, and it's going to reuse that instead of going and creating a different instance and occupying some memory in your application. And if you want to try with a different one, so let's just go and say that we have a p9 as well, and let's try to go and send a different one over here. And for that, let's just go and duplicate this one as well, and I'm going to check with the p9 over here, and let's just go and check if this is of the identical over here as well. And p7 and p9, let's try to go and check this one, and let's try to run this one. P9 and p7 and p9 are not identical, it means that this is not the same object, right? So this one and this is not the same object, but this one and this one is the same object. It's reusing it. And let us also try to test with the if that's not the case with the, let's say, our final, and I'm going to set this one as the final as well, and let's just go and make this one as the final as well. So let's try to see what's the result over here. And this is not identical, this is also not the identical. So here this is not the identical because we have removed the const over here. So that's the case over here. So if I want, I have to go and make use of the const variable as well over here. So const. So that's why we say the const is good for the memory management in your application. that's a big difference with the final and the cons. So if you make use of the cons, you can save a lot of the memory actually in your application by reusing, by allowing the Dart to reuse the identical objects, right? So it doesn't have to go and create a lot of the objects, which is basically not required and not good for your application. You can also support me by purchasing one of my courses from my website, which is wecancode.in and /courses. There are the courses related to the Flutter, full stack development, Python, and React Native as well. So make sure to go and check out the courses in my website. Let us try to go to this particular constructor over here, and let's try to make this particular parameter or the constructor parameter that we have as a named parameter, right? So let's try to go, and we have learned this one previously in our function. So how we can add the named parameter. So what we have to do is we have to set this one as the requi required, right? So required, as well as this one should be of the required. So now the x and y, or the parameter or constructor parameter over here, is the required one, as well as it's the named one. So named I have to give as a x, as well as I have to use a colon and give this as a y. So now our constructor for this one, right, is we have set the required, as well as this is now the named parameter. Let us go back to our readme.md file, and let's go down over to our this keyword. So let's try to see, and let's try to go and see what is this keyword, and we had already used over here, right? So let's try to understand that one. That this keyword in the Dart refers to the current instance of a class, and is primarily used for the following reasons. So one is to distinguish between the instance variable and the local variable or the parameter that has the same name. If you go to the constructor, here we have this x and this y. So this basically means the instance variable that we have defined over here, right? And let's go over here, and then it also has another one, which is to pass the current object as an argument to the another method or the function. So using this, we can also pass the current instance of that particular one to the another argument as an argument to other methods or the function as well. In a generative constructor, this the field name is a shorthand to initialize the instance variable directly from the constructor parameter with the same name. So let's try to go and see how we can practically make use of this one. So for that, let's go to the file and create the this_keyword.the file over here, and let's try to add the one class over here. So let's add the class, and class name as let's create the product one, and the product can have the first is the name, right? And then we have the double, which is of the price, and we will also have the string type, which will be of the description. So let's have the the instance variable over here, and now I can just go and create the constructor for our product over here. And for this particular product, I can use a shorthand like what we have done previously. So this dot the name comma this dot the price that we have, as well as this dot the description that we have set up over here. And this is just the one way of setting the constructor parameter. And the next one that we saw previously in the constructor, that how we can also make use of the named parameter in our constructor as well, right? And the another way that we can also go and initialize for this one is, let's try to go and okay, let me comment out this one, right? So let's try to see how we can do it on a different way. So let's say a product over here, product constructor over here, and I can just go and take something like a string and the name each n, and then I can also have the double, which will be of the d, as well as the string type, which will of the, let's say the, okay, so let's say this is also the d over here, and this one should be of the price as the p over here. And once we set up this one, I can just go and add the colon over here, and I can just go and say the name will be of equals to the n that we are getting in, and then the price that we are getting in should be of equals to the p, and then what we have next is the description, right? So description can be or is equals to the d that we have define, right? So let's just go and close it over here. This is another way how we can create the constructor over here. And then the another one what we can do is we can also go and actually go and let's try to comment out this one. First of all, let's try to comment out this one, and let's try to go and create the product over here. So product constructor over here, and in the product constructor, let's take the same. Okay, so let's just copy this one from here. Let me just copy this from here, and let's try to paste it over here. And now I can open the constructor body, and I can just go and refer as this dot the name that we have will be of equals to the name or the n that we are getting in, right? And then this dot the price, which will be of equals to the p, and then this dot the description that we have will be of equals to the d over here. So this is how we can actually go and set up over here. It should not be of a comma. Let me add the semicolon over here. And okay, so nullable field description must, okay, so this must be initialized. So here it's actually, so what I have to do is I have to go and make it as a let over here, right? If you want to use in this way. So there are different ways of how we can actually go and make use of this, and how we can create a different type of the constructor, right? But the shorthand that we are using generally is this one, right? So this is the shorthand type that we can use using the this dot the name, this dot the price, this dot the description over here. And let's try to add one more function over here. So let's create a function or the method over here. So let's say compare, we want to compare the let's say a price over here, PRI, say price over here, and we are going to take in the product as the function or the method argument over here, right, or the parameter over here. And then let's say this is of the p over here, or let's not say the p, I'll just go and say the another, let's say another, right? So PR this product over here. And let's try to go and compare. Let's say if this, which means the current object that we are in, this dot the price, right? So let's say this dot the price is greater than what we can say the other OTHER other, or okay, so not the another product that we have, another product dot the price. Then we want to do something like the go and print out something like the let's say let's try to go and add the string interpolation. So I'll just go and say, okay, let me just go and say the string interpolation of this dot the, okay, this dot what we have the price, or this dot the name. So let's access this dot the name each more, right? So expensive, right? exp and sib expensive over here. Let's try to close this one. So here you can see that we can make use of this keyword to access the current instance variable, right? So this basically means from the price from this particular instance, and here we are getting the another instance as a method parameter, right? So let's try to go and let's try to go down, void void main, and let's try to go and add that, and let's create the instance of the product. Let us create the let's say var, and I'll just go and say the p1, or we can also say the product, right? So product p1, which is just equals to the product, right? So let's just go and define we have to keep the n, right, p, and then the d. So let's go and say the n will be of the name, will be of, let's say a laptop, laptop, laptop. And then the price, let's give something double as the 220, and then the description, which will be of the laptop, or the, let's say a Asus laptop over here. Let's go and close this one, and now I can just go and say the p1 and then the dot over here, and I can access the rest of it. And let's try to go and say the another one. So let's say product over here, you see the product p2, which will be equals to the product as well, and then the name will be of the, okay, so here is one string, so I need to remove that, and I need to set this one as a string. So that's why it's coming up string again and again. So this one will be of the mouse or something, right? And let's say the price will be of the 20, so it should be of the double 50.20, and then the description will be Asus, let's say mouse over here. and let's try to close this one. Now let's try to use a compare function. So p1 dot the compare over here, and I need to pass in another product which will let's pass in the p2 over here. And if I go and run this one, I should see that the laptop is more expensive, right? So this is how we can make use of this, that the price is for the current product, as well as the another product that we are passing it as the parameter is the instance of the another product that we have created over here. And I hope you got the idea how we can use this keyword and what is the use case of having this keyword over here. Let's go back over here and try to go and practice it more so you can get more idea about it. Next is that let's try to go and learn about the getters and then the setters over here. And if you look into the description over here, getters and setters are special method that provide the controlled access to the class properties or the instance variable. So if you want to have some controlled access to all of your instance variables, at that time we can make use of the getter and then the setters. This allows you to define a custom logic for reading, which is the getting, right, and also for writing. So for reading and writing the our variables value rather than directly exposing the underlying variables. This is a core concept of encapsulation. So once we are learning about the encapsulation, one of the pillar of OOP, right, we will learn about it more, but let's try to see how we can make use of that. So in implicit getter and setter over here, by default, right, Dart automatically generates a implicit getter as well as setter for every public instance variable, and unless it's final or const, in which case only a getter is generated. For the variable that is defined as the final and const, it has only the getter generated, right? For example, let's say you have a string name and it implicitly creates string get name as well as the set name. And let's try to look into the explicitly setting the get and set keyword. So you can define a custom getter and setter using the get and set keyword. This is useful for validation, right, ensuring that I meet certain criteria before setting or before being set, right? So once you pass in some value and before setting it, that you want to set add some validation to that one. And the computed properties, calculating the value based on the other properties rather than storing it directly. Side effect, right, performing the additional action when a property is accessed or modified. And read only or write only properties by providing only a getter or a setter. So let's try to go and create, or let's try to go and see how we can make use of getter and setter in a practical way. So let's go and create the getter and setter over here, and we are going to create our class. First of all, let's create a circle class over here, and let's have a double, and I'll create a private variable over here that will be of the radius over here. So here we have the radius, and let's create a constructor for this one, right? And for the constructor I need to use a shorthand this dot the radius over here. And now if I go down to the void main method over here, and in the main method if I try to create the circle which will be of the c1, and then I'll go and create the instance of the circle, and in the one I need to pass in the double. So let's just go and pass in something like the 10 over here. And if I go and c1 dot, I still can access the radius because this is in the same file. So for the private variables, right, you can actually go and access it from the same file. But if I go and create the new one over here, let's try to go and say the main dot the dot over here, and in the main dot the dot, let's just go and have the void main over here. So sorry, it should be of the void void main method over here, and let's create the circle. So let's import this circle over here, and let's have the c1 which is be of equals to the circle as well. And radius, I'll just go and pass the 10.50 over here, and I try to go and access the c1 dot notation, and you can see that the private variable cannot be accessed over here, right? So that's the difference. Let me just go and remove this one for now, or let's just go and keep it over here. So let's just go back to the getter and setter. Actually it's in the same file. You can see that it can be accessed in the dot, right, because it's the same, the file is in the same package, right? And in the dot we can say that this particular file is one package, right? If you try to go and access it from the another package, right, so each file is one package in dot actually. That's why we are unable to access that particular over here. But in the same file or the same package, you can actually access the private variable over here. And now let's try to go and create the getter, right? So if I go and say the circle, and if I try to go and print out this one, so let's say I want to print out the radius over here, I can already us radius. Let's just go and say the c1. Okay, so I need to use the c1 dot the okay, I need to have the dollar sign away, c1 dot the radius over here, so I can access that, right? Let's just go and close this one. And if I want to go and set the value for radius as well, so if I go and say the c1 dot the underscore the radius, which can be of equal to 20.50 as well over here, and you can see that we are not going to get any of the error as well. So let's just go and copy that, and let's try to go and paste it over here. Let's try to run this one. You can see that the first it was 10, and the second it can be of the 20.50, that what we have to. But if you want to control this particular variable, so let's say if you want to only get it but you can't go and set it for now, so let's try to go and set the, by default it's always create the getter and setter for you, right? But let's try to set it as the, I need to go and set the getter. I'll just go and set the get, and then the I'll just going to get the us radius. So I want to get the radius, and it's going to return me the current radius or the instance radius, right? And if I go and try to run this one, and okay, so we can actually go and run that one, but let's try to go and do the same thing from here. So if I go now and c1 dot, I can get the radius, right? But I cannot access the private variable that I have defined, right? So if I go and say the c dot the okay, so I don't have access, I have only access to the radius, and this is the getter, so it's, you only can get it over here, right? If I go and try to set the value of 40.25, it's not going to work because we have set that one as the getter only. But in the same file or the same package or the library that we have defined over here, you can see is accessible, right? Or and also you can go and set the value, it doesn't matter. But once you are outside of that particular package, you can see that you cannot set that one, right? Suppose if you are importing that particular class somewhere in the another file, and if you want to access that, you can access it, but if you want to set it, you cannot go and set the values. You only have the getter over here, and you don't have a setter over here. So if you want to go and enable the let's try to go and set the setter. So let's say we want to set a value for this particular radius from the another package as well, right? So let's try to go and create the setter. For I'll go and explicitly make use of the set keyword over here, and I'll just go and say the radiu, a setter radius, and here we are going to grab the double, and in the double I want to get some value value, and with this particular I'm going to access this dot the radius will be of the value that we are actually grabbing in over here. And then now if I go back to this one, okay, so let's try to go and see from here c1 dot, I can just go and set the radius over here, right? And in the radius I'll just go and say the 50.60 over here, and I can do the same thing from our the main method that we have defined over here. So now I can go and actually set the radius as well. Previously it was not accessible, so if I go and use the dot notation, I have access to the radius as well over here, right? So radius, and I can now set the value because we have explicitly created a setter. So this is a setter and this is a getter over here. And as we saw that we can also add some validation and side effects and all of this stuff. So let's try to go and see how we can actually do some validation. So let's say I want to go and set the check the condition, so value that we are passing in. So let's say a value that we are passing in is equals to greater than equals to of the 0, then we are going to set it, right? So let's say we want to go and set that particular value, and let's try to go and format this. And on the else case, so if it's not the one that we are going to say, we are just going to say the printout value over here, and we are going to say the error or something like so, error error, and the radius cannot be a negative number or the negative value or something, right? So let's try to go and try to set that one from here, and I'm just going to give it as minus value over here. And now I can just go and try to run this one. You can see that the radius cannot be of the negative value. That is what we have added over here. So added the RUS actually. So this way we can create a custom setter and add some validation. And if you go back to the readme over here, you can also do something like compute properties, adding side effects, and a lot of those stuff. So let's try to go and add some one or two more examples. Let's try to go and add the area calculation over here. Area is calculated on demand, not stored. So here you are going to get the area, and then you have added some logic for that one, right? So if I go back over here, and now if I go and access the c.the area over here, and if I go and try to run this one, so let's try to run that one. Okay, so we have to actually go and print out this one. All right, so print. Okay, so let's go and print out this one over here, and let's add this one over here. Let's just go and close it over here, and that should be good enough. Okay, so let's try to go and format this. Let's try to run it over here, and now we got the area over here. So now if I try to go and actually go c1 dot the area, c1 dot the area, so you only have our setter or getter, but you can't go and set the value for this one, right? So this is how we can add some encapsulation over here. We are going to learn more about it once we start learning OOP and the encapsulation, right? And so let's try to add one more. So let's say if you want to have the if you want to get the so let's get the double, and let's say the get, and let's say description over here, description, and then you are going to return something from here like the circle with the radius, RADIUS radius, and then our radius value that we have defined. Let's try to go and close it over here. Okay, so this is a double, not a double. I need to go and return this string from here, and now I can just go and only go and so c1 dot the description. So this is a description, right? I can just go and print out this one. Let's try to go and print out this. This will be of the description over here, but we cannot go and set this one, right? So we only have the getter, but we don't have the setter for all of this. So this is a getter to get the area, and this is a setter to the getter to get the description as well. And if we go back to, okay, so let's try to go and run this one from here as well. And if I try to go and add the negative over here as well, try to run, so you can also see the validation is working as well, right? But to test this one, you need to create a separate file to actually go and make use of the encapsulation. And to test it, you need to create a separate file. You try not to test it from the same file or the same package, then the result may not be correct, or it may not be the same as you expected, right? Now let us try to go and learn about the encapsulation, and some of the part we have already learned in the previous session already, which is in the getter and the setter. Let's try to see what is encapsulation over here. Encapsulation is one of the fundamental principles of the object-oriented programming, or the OOP programming. It refers to the building of the data or the attributes and methods or the function that operates on the data within a single unit, which is a class. So single unit basically means in a class. And it also involves the restricting of the direct access to some of the object components, preventing unintended external interference or misuse of the data. So in the data, encapsulation is achieved primarily through the underscore prefix for a private member. So we have learned about the underscore prefix already, how to create the private function, how to create the private variables, and all of those stuff. In the Dart, the private member is basically starts with the underscore prefix, and in the Dart there is no public, private, or protected keyword like some other languages. Like if you're coming back from the C++, Java, right, and you have the public, private, protected, and other keywords, right? But in the Dart we basically don't have that. Instead, visibility is determined by the underscore prefix. A variable or a function or a class member properties or methods whose names start with the underscore is private to its library, meaning the Dart file that's declared. So previously I have mentioned that this particular each file is one library in the Dart, right? So this is one library, this is one library, this is one library. The Dart internally says that this is one library, each file is one library. So that is what it's trying to say over here. This means it can only be accessed within the same file. So we saw previously how it can be accessed within the same file where it is declared, and it is not truly private to a class. It is not truly private to a class. That's what we saw previously already, but private to a file or a library. This is an important distinction in the data. So you may be a bit confused if you are coming back from the Java or C++ or the .NET framework, right? So this is an important distinction over here, right? It's private to a library or the file. So it's private to each file actually, if you want to say it in that way, right? But .internet sees each file as a library over here. And let's try to see controlling the access to the class member, right? By making the instance variable private, right? So by underscore, you prevent direct modification from the outside library. Outside library means from the another file, right? You then provide a public method, getters and setters, to control how these private variables are accessed and modified. We actually saw this one previously already. This allows you to add validation, logging, and other logic before data is being read or written. So you can actually go and set different validation, loggings, and all of this stuff before we read or write the data. So let's try to go and see or create some practical example over here. Let's go and create the file that is of encapsulation.data over here, and let's create one a class over here, and that will be of the, let's say, a bank account. So let's try to create a bank account. In the bank account, let's say we have a variable of the private, which is of the account name. So we want to have a controlled the controlled version of our bank account, right? So it's a really restrictive. Any of the bank account details and all of those stuff are really restrictive. So let's try to stimulate it over here. And one is of the double, and that will be of the balance, right? So balance, 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 and then we have, let's say, a string type of something like the account name or the account holder or something, or account number. Let's try to go and have the constructor for this one, bank account. And here I'm going to try to set this dot the we have the account name, as well we have the this dot the we have the balance, right? And then we also have the this dot the account holder over here, and I can just go and set this one over here. Or else what we can also do is I can just go and say the underscore the name and then the balance, and this is of the, or I can just, instead of saying the initial balance, I'll just go and say the, okay, not the balance, initial balance, and then the account holder. Okay, so this is of the account holder, and I may try to go and set some logic over here. So let's try to go and remove this one from here. The name isn't, okay, so here this that name is not defined, so we don't have this that name. Okay, so we have the account name actually. So let's try to go and set this out the initial balance. Okay, so we also don't have that. Let's try to add that one, and actually let's try to go and set print out the information over here. So initial balance, account created, let's say account here created over here. For the, we have the what we have is the account name, right, or the account holder over here. So account is created for the account holder with the balance, of what we have is the balance, right? So let's try to set this one over here. So this is the initial setup. Once we create the bank account, this is the initial setup that we are trying to do over here. And I think instead of setting the balance over here, let's try to set the initial balance over here, and here I'm going to set this one as the balance that we have, right? So the balance that we have will be of equals to the initial balance that we are going to actually receive. So I need to move this one to the end over here actually, right? Okay, so this dot the initial, not the this dot the initial balance, so this one should be actually the double over here, double dot the, let's say, the initial balance over here. So this is what we are going to set up over here. And why I created the initial balance is because this is for the initial balance. Once we create the first account, so initial balance we want to pass in, right? And then let's try to, we cannot actually go and move this one to here, it doesn't matter actually, right? So it doesn't matter. So let's try to go and set that one. And now let's try to go and make use of this one. So bank account, let's try to go over here, and let me just try to comment on this one, right? And let's try to go and have the bank account, and let's say B1 which will be of the bank account, and here we need to add the name. So let's say the account name, initial balance, let's say I just have the 500, and then the account holder is actually the string. Yeah, account holder is also a string. So let's say this is of the something like a D1 or something, right? So let's just go and add that one. And now if I try to go and okay, let me just try to comment out this one. Let's try to run this one. You should see that the account created for the one with the balance of this one, right? So that is what we have added over here, which means that initial balance has been activated for our account, and account has been created over here. And if you go back to our main file over here, and in this particular library, if I say the b1.d, I don't have access now. I cannot access any of the properties over here, right? So I cannot go and access the account name, balance, as well as the account holder. So let's say that is not good, right? So as a user, they need to access mainly the balance over here. So what we'll try to do is let's try to set the let's try to return our double, and this is of the getter. So I will say to get the balance over here. So balance balance over here, and we are going to return the balance from here. So underscore return type will be of the balance over here. Or you can also go and do some validation, right? And from here you are going to return something like the return the underscore the balance from here, and you can add some validation and do some logging, right? So every time the user is accessing that particular balance, you want to do a counter, like how many times in a particular minute they can access. So all of those validation actually, so like in the real world, like if you try to access a balance multiple times in let's say 1 minute, then your account may get blocked or temporarily get restricted and all of this stuff, right? So you can actually do that kind of setup over here, right? And now I can just go and say b1.d, I can go and access the balance now. So I have a getter over here, right? I have the getter. So let's try to go and say this is a print. So I want to go and access my balance. So for that, I'll just go and say balance over balance balance over here. Balance will be of the b1.d balance over here. So let's try to access that, and let's try to go and print it out over here. So we got that one. Okay, so let's try to remove that balance balance over here. Let's try to run that, and we got the balances of the 500. Now let's say a user want to add or top up or add some more balance, or want to deposit it, right? But now currently we don't have any way to go and actually deposit to our account. So do you that, can you add balance or no, right? So what we'll do over here is let's go back and let's create a method to actually go and deposit it. So let's go and say have void, and then give USI to deposit. I want to deposit double over here. So let's say double UOU double, and then let's say our value that we have or amount. And here I'm going to say I want to add a validation. So I want to go and say if the value that we are passing in is of greater than of the 0. So you cannot go and deposit of 0 or let's say or minus 1100, right? So let's try to go and add some validation. I'm just going to say the balance will be of equals to so the balance that we have will be of the current balance plus the value that the user has passed in, right? I'm going to add that one. Otherwise I'm going to say something like the add some validation, and I'm going to print out something like the deposit number should be valid, or let's say should be positive, right? Or positive number or something. So let's just go and add that one. Now let's try to go back over here, and let's try to also go and print out over here. I'm going to print out something like the deposited. I want to go and have a deposited how much you are going to deposit. That will be of the value that we have deposited over here, deposited a value, and I'll go and say deposited a value to okay, so let's say a deposited value for the account holder, and I'm going to say that the account holder will be of the, okay, so we have the account holder over here, and then the let's say a new balance will be of the balance that we have over here. Let's try to go and set that. Let's go back over here, and if I want to set the let's say deposit over here, now I have access to the deposit, and in this particular deposit I want to go and deposit the minus 500 over here. Let's try to go, and now you can see that the deposited numbers should be positive. So validation is working, and I want to go and add the another 400 to my deposit. So let's try to go and run that. Now you have deposited 400 for account holder day one. New balance is of the 900, right? So we got that, right? And now I have a 900 in my account. And if I go back to here encapsulation, so I can do the same thing for the getter for our get the what I need is the account, let's say account holder or account name. So let's say I want to go and grab the account name, and I'm going to return the account name from here, right? So account name over here, and the same thing that I can do for my get the account holder, and I'm going to return that as the underscore the account holder over here. So in this way now I have a controlled version. I can only get the account name and I can only get the account name, but I don't have a way to go and set that one. So where I can set it only at the time of the account creation. So if I go back over here now, if I want to go and access the one dot, I can access the account holder account name, but I don't have a way to actually go and set it once it is created. So this is how the encapsulation actually work, right? So you control how it can be set, how it can be get, right? So this is the encapsulation actually. So how you are going to control read and write access to our instance variables, methods, and so on. And we can also go and add the one more function. Now we have option to deposit, but we don't have our option to withdraw. So like you have a bank, you have a money in the bank, but you don't have option to withdraw, right? So that's not a correct way. So let's try to add one more logic to withdraw, right? So WITH and I need to pass in the amount over here, let's say the amount over here, and how much I want to withdraw. So I need to do the validation, right? Without the validation I cannot go and actually withdraw the money. So let's say the amount that we are passing is it should be of the greater than the 0, and also, right, I also need to check that the underscore the balance that we have also need to be greater than or equals to the amount that we are passing in, otherwise we cannot go and withdraw that. So let's try to go and set a new balance. So balance will be of the minus equals to minus the current amount that we are passing in. And now I can just go and print out the message over here. I'll do some logging over here. Why not we just go and create the private method over here. So void underscore the log over here, and with this particular log I will have to pass in this string, let's say a type over here, and then the message over here. So right, so message or something like. Let's try to go and print out this one, and then I'll just go and say let's say the type will be of the type that we are passing in. Let's say or I'll just go and create a new line for this one, and I'll just go and say the message will be of the $sign the message that we are passing in. And now once we have that, I can actually go and make use of the underscore the log over here, and I can pass in the type each of the withdraw, and then the message will be of the something like, let's say our amount, or let's say the dollar amount, or the dollar amount has been withdrawn from the account holder underscore the account holder over here. So let's say we have that, right? And then now let's try to go and add other validation. Else I want to also go and check for something like, or not the else, maybe I'm going to else if over here. Let's add another validation over here. Else if the amount that we are passing is actually less than, let's say they are passing in the less than equals to the 0, either 0 or the less than equals to 0, right? Here we are going to go the log. I want to go and log and type each of the error and message. I can just go and say something like the withdraw. So WITSD error withdraw. Okay, I need to be in the string. WITSD error withdraw amount need to be positive, right? Why this is over there, positive positive over here, and let's just go and have that. And also I guess in the final case, in the else, I'm going to say something like I'm going to log this one as well, and let's try to say the insufficient, right? Insufficient fund over here, and I'll try to say the current balance, so BALANCE balance is current balance is lower than amount to withdraw. So let's try to go and have that. And now if I try to go to the main, and if I try to go and say I want to go and have the B1 that I want to withdraw our money. So let's try to go and withdraw it, and I want to have a 4,000 to be withdrawn over here, and let's try to go and set that. So message current balance is lower than amount to the withdraw, and if I go and set the negative value over here, I should also do some validation. Amount need to be a positive number, and if I go and say I want to go and let's say a 500 to be withdrawn, let's try to go and run that. Message has been withdrawn. So all of the validation is actually working good. And also if I want to go and access that particular private method p1 dot, then it's another p1 is to give the b1 dot, and you don't see the particularly the private method that we have defined, which is the logging over here. So this is the encapsulation. So we saw how we can make use of the private field as well as the private the methods, right, and to that operates on the data within a single unit in the class. It involves the restricting the direct access and to some of the object components, preventing the unintended internal interference and misuse of the data, right? So this is what we saw in encapsulation, and we saw practically how we can achieve the encapsulation in the Dart using the prefix of the underscore. This is the private variables as well as the methods that we have defined in our class over here. So this is a private method, and this is a private variables or the instance variable, right? And using this, this is how we can achieve the encapsulation in the Dart. Let's just try to go and remove that over here. So I hope you got the idea about how to what's the encapsulation and how we can go and implement it in the Dart using the underscore prefix. So this is one of the fundamental principle of the object-oriented programming. Now let us look into the polymorphism over here. And if you take a look over the explanation over here, polymorphism means many forms. It's the ability of an object to take on many forms. So one object can take on many forms. In object-oriented programming, it allows object of a different class to be treated as an object of a common class. So let's say you have a common class of animal, and you may have a different subclasses like let's say a cat, dog, right? They can be treated as a different class to be treated as an object of a common class, which means that the class of the cat, dog can be treated as a common class of an animal. This means a single variable can refer to an object of a different type, and a single method can behave differently depending on the actual type of the object at a runtime. So here you can see that this means a variable, right, can refer to an object of a different type. Let's say a variable of an animal can refer to an object of a cat, dog, right, cow, and so on. And a single method call, let's say you have let's say a call of the it method, it can behave differently depending on the actual type. Or let's say it method in a cow can differently, and it method in a cat can behave differently. Like a single method call can behave differently depending on the actual type of the object at the runtime. So basically at the runtime, so you may have just a one method, it method in both of the cow, cat, right, dog, that gets inherited from the superclass which is of the animal, but it may behave differently, right? So you may run a different functionality at a runtime. So we will see that practically. Don't worry, at a later stage we are going to see how all of those are done practically. And let's take a look over here, definition or an example over here. So polymorphism is often demonstrated through a method overriding. So basically we need to override a method from a superclass in a child class. As seen in the inheritance, we have already done the practically in the inheritance how we inherited a parent method class in a subclass, and through typecasting as well. The key idea is that you can write a code that operates on a base type, which is basically a parent class, and that code will correctly execute the specialized behavior of any derived type. Runtime polymorphism. Basically, there are two types of the polymorphism we can say. So one is of the runtime polymorphism. Runtime polymorphism means that the method behavior is decided while the program is running. So once you execute that program, the behavior of that method is decided at the once the application is at the running state. So that is a runtime polymorphism. This is commonly done using an inheritance, right? We inherited the parent class and we override that particular method, right? So superclass reference holding a subclass object. So we have already done that actually in the inheritance as well. And the next one is the compile time polymorphism. So the compile time polymorphism means that the method behavior is decided before the program runs, right? Before the program executes, the behavior already is decided. In many languages, this is done using a method overloading, but in the Dart, we don't have that, right? So but in the Dart, it doesn't support the method overloading. But if you want to go and take a look, you can go and search for the Java, and basically you can find a lot of the Java and the C++ how you can make use of the method overloading. So if you have done the Java in your universities, then you should already know about the method overloading. So just make sure that the Dart only supports the runtime polymorphism currently, right? As of now, the Dart only supports the Dart runtime polymorphism, but not sure, maybe in the future releases that it may support the compile time polymorphism as well, right? But now we need to take a look into the polymorphism at the runtime. And in Dart, you can see you usually handle this using the optional. So if you want to make use of a compile time polymorphism, in Dart it basically doesn't support it, but you can obviously go and use something like the optional parameters, which we have already looked into, named parameter, which we have done as well, right? Dynamic generics and so on. So let's go into the practical and let's do some let's go and see how we can do it in a practical way. So I have added one file which is the polymorphism.dart over here, and what we'll do is we'll go to the inheritance over here because we will be using same concept over here. So let's go on to the top and let's copy this animal class from here. Let's just go and copy this and let's just go and paste this over here. So we have a class animal now which has the name and then the age as the instance variable over here, and we have the animal constructor. We already know that this is the constructor, and we have some methods over here which is of the eat, and then we will have eat, sleep, and then the make sound over here. Or we can also go and just go and remove this one from here. Let's just go and have this a 2 which is of the eat and make sound over here. And now let me just go and add some comment over here, so just to have you understand what we are going to do over here. So let's just go and add this is a superclass or the parent class, right? And the different subclass will use this common animal tag. So we have already read the documentation, so that's what we are adding over here. So next what we'll do over here, let's just go and add the subclass as well. So let's go and let's copy this one from here. We are going to copy the dog from here, right? Just copy the dog and paste it below over here. And this particular dog we have something like it's going to extend from the animal which is of the inheritance over here. And let's just not have the breed over here, so we are not going to use that one. but we are going to have the constructor, so the name and then this one. So let's just go and remove that. So we have the name and then the age over here. So we are calling the super constructor, which is of this one, and we are passing the name and then the age for this particular constructor over here. That's fine. So we are calling that, and then we are just going to print that this is also perfectly fine. So now otherwise you can just go and remove as well. If you don't want to print out, you can just go and remove that as well. It doesn't matter. But now we have to go and override the two methods over here. One is to go and override our make sound, right? So make override the make sound over here, and we are, let's just go and have, okay, so let's just go and, okay, so let's just keep that it for now. And in the make sound, what do you think that this is a generic one, so this is making sound, right? So the name is making noise, woof woof woof. But what we want to do is for the dog, we just want to say something different, or maybe we can use the same thing. So let's just go and copy this one from here, and let's just go and have over here. And here for the animal or the generic the parent class, we are going to say it's making noise, and just go and remove that particular hoof from here. That should be good enough. So now we have make sound override, and we are going to have one more method over here. So let's just go and have the void, and then we want to just go and wag a tail over here. So let's say dog is wagging a tail over here, and we want to just go and print out this one. So name is not making a sound, we are going to say that it's wagging a tail, right? So it's going to wag a tail over here. So we have one method which is overridden from our animal class, which is of the super class, and we have our own method which is of the dog, which is wag a tail over here. So only a dog can wag a tail, not a cat, right? So let's just go over here, and we will copy the another one which is of the cat one. Let's go back over here, and let's go and paste it over here. So now we have the another one, right? So let's just go and remove the breed over here because we are not going to use that. So let's also remove it from here, and we are not going to use this one as well. So let's just go and construct the body. So let's just go and clear it out, right? So let's just go and close it over here. And now we want to override our make sound. That's fine. And name is making noise, meow meow meow. That's for the cat over here. And cat also can climb a tree, so let's say it's climbing a tree over here. That's perfectly fine over here. Next we are going to have one more. I guess we have one. Okay, so we don't have anymore, but let's just go and have one class over here. Just going to just copy this and paste it over here, and we are going to have not the cat, let's say a cow over here. We are going to have a class cow that's going to extend from the animal, and we will have the cow constructor over here. That's fine. And now we are going to override the make a sound for the cow, and the name is making a noise which can be of the moo, right? So moo moo, right? So that's how the cow is making a noise over here. And now the cow cannot climb a tree. What it can do is it will graze. So G-R-A-Z-E, I guess. And then the print name is not climbing a tree. It's G-R-A-Z-I-N-G, grazing, right? I guess that should be fine over here. So now we have a four class, right? So one is our parent class that we have, the super class, and then we have the class which is of the dog subclass, and then the cat as well as the cow over here. A total 4 class. One is a parent class, 3 is a subclass over here. And let us add some comments. So just to be more clear, the dog is a subclass of animal, as well as we have the cat over here, right? So let's say cat is a subclass of animal, as well as we have the cow over here, which is also the subclass of the animal as well, right? And now over here, the make sound we have overridden from the animal, right? So in the animal we also have, in the animal we have that particular make sound, right? But we have overridden that in our subclass, all the subclasses which is of the make sound. So let me just go and add one comment over here, which is a dog gives its own implementation of the make sound. So here it has own implementation in the parent class, but in the subclass we have overridden that and implemented in our own way, as well as in the cat as well. So let's just go and add that comment over here as well. So I'll just go and say this is a the cat gives its own implementation of make sound, as well as our cow gives its own implementation, right? So it's not forced to use the what the animal is having, but we can override that and we can implement our own logic over here. And as well as the let's just go on to the top over here. And for the wagging tail method, this is method belongs to the dog only, right? Only dog has the wag tail method, and then the only this particular method is available in the cat, right? So this is for the cat over here, and this is for the grace, so it's only available in the cow. So rest of the two doesn't have that, right? So I hope you got some idea over here. And now let's go and see the actual implementation of the polymorphism over here. So for that, I'm going to create the void main method over here, and here let's try to implement our polymorphism over here. So first we are going to create the instance of the animal over here. Animal, let's go and say the animal so it should be of the animal. Let's create of the one over here, and this can be of the dog, right? So we have the animal dog. Name, I can just go and say the feeder over here, and then the age can be of something like a 4 over here. And let's just go and close this one over here. And same thing, we can have the animal, and let's say this is of the animal 2 over here, and this can be of the cat over here. And cat, let's just give a name of the Luna, I guess, and then the age we are going to give it as a 2 over here. And third, we also have one animal class which can be of the animal 3 over here, and that's going to be of the cow over here. And let's say the cow name each of the BSSI is C over here, and then give a name of something age of the 6 over here. And this is the okay, so let's just go and print all of this over here. So we are going to print the object that we have over here, or let's just go and implement something like the animal 1 that we have, actually animal 1 dot make a sound, right? So 3 different object that we have actually over here. So animal 2 has its own implementation of the make sound as well, and then we have the animal of the 3 that has its own implementation of the make sound over here. But what I want to show you over here is this one, right? So the type you can see actually each of the animal, and animal. So all of these is the animal variable type each of the animal for all of these 3, but the actual object is a different for each of those, right? So first one is a dog object, second one is of the cat, and third one each of the cow. Different object over here, but the variable type each of the same. How that's possible? This is actually polymorphism. One object can have a different form, right? So animal object, which is of a single type, can have a different form. So it can form as a dog, can be act as a cat, cow, and so on. This is actually a polymorphism over here. And let me add a small comment over here. So as you can see over here, the variable type each of the animal, but actual object are dog, cat, and cow. This means one parent type can refer to a many child class object. So this is a polymorphism. We already saw in the documentation over here, like where the polymorphism, if you go over here, then take of a many form over here. This means a single variable object, a single variable can refer to an object of a different type. This is what we are implementing over here. So one type, one variable type can have a different type of the object over here. So this is the one of the condition that we saw. This means that a single variable can refer to an object of a different type. A single method call can behave differently depending on the actual type of the object, right? Let's try to see one more example over here, and let's just go and create the list over here. And the type I'm going to give for this one is the animal. So let's just go and create a list of the animal. So it should be of the list, the list of the animal, and I'll just go and say the farm animals, right? So animals. So we have the farm animals, and let's have the list over here. In this list we are going to give something like the dog, and the dog name, let's say Rex over here, and then the age is of something like a 5, and let's have the cat as well over here. Cat will have something like a meters, let the meters, M-E-T-T-E-N-S, mittens, I guess. So let's have the age of the 3, and then we have the cow object as well, and in the cow we are going to say this is the daisy, right? So the D-A-I-S-Y, daisy, and age, let's give it of the 8 over here, and then we also have the animal itself. Animal can be of, let's say B-R-I-D-I, and then the age is of the 1 as well over here. Let's just go and close it over here. So now we have a list of the animals over here, which holds a different type of the object over here: cow, cat, animal, and so on, right? So but the list type is of the animal, which it can hold a different type because we have the inheritance extending that particular animal over here. That's why we are able to add it over here. If you change that to dog over here, then we can't go and make use of the other type because dog is not an animal. But if I say that this is the list is of the animal, dog is an animal, cat is an animal, cow is an animal, as well as the animal itself is an animal over here as well. So now what we will do over here, we are going to go and see how we can make use of the for loop for this one. I'm going to go and say the animal, for animal, which is of the type is of the animal in our farm animals, right? So once we got that, inside this we are going to say that the animal, so animal dot we have the, I guess, the it. Every animal has the it method. That is what we have defined over here, but we haven't overwritten that since we extended the animal, right? So we inherit that particular method as well. So all the animals should have that particular it method because it automatically gets inherited, right? So that's the inheritance over here. And also it has the animal dot the make sound. Everyone has a make sound. Every animal can make sound because that is what we have added over here. So it and then the make sound get inherited on all of our subclasses. That is going to extend from our animal class. And now if I go and try to say that the animal dot I can't go and see our dog weighing our tail, cat going to climb, or the cow going to graze. Why? Because the animal actually doesn't have that. So what we have to do over here is we have to check for the condition if the animal each, right? If each a relationship, animal each a dog. So if an animal each a dog, then what I want to do over here is the animal dog animal dot I can go and say weighing a tail over here, right? And also else if our animal each a cat over here, sorry, animal each a cat over here. So what the cat can do over here, so the animal dot can climb a tree over here, right? So and else if as well over here, if the animal eats a cow, then what's going to do is going to go and let's call the animal dot the graze over here. So animal can go and graze over here as well. And let me add some comment over here. So just to make you guys understand over here, let's just go and arrange this one properly. So you cannot call a wag tail directly because animal is declared as a animal, right? So type each of the animal, and the animal doesn't have a wagging tail method. That is not what we have defined in this particular animal class. As well as if you go over here, if you need to specifically call the method that's in the subclass, you should use type checking over here. So we need to check a type. If the animal is a dog, if the animal is a cat, or if an animal is a cow over here, right? So it's a type checking and casting. You can also make use of the type casting using as well over here. And let me also add some over comment over here. This is the safe to call because all the animal can eat. This is inherited as well as the another one, which is of the make sound, which is actually a polymorphic call because we have changed it on the subclass, right? So what we have done is we have make use of the runtime polymorphism, right? So which is making use overriding that particular method and doing our own implementation in the subclass over here. And also the below over here, which is of the weighing a whale, this is safe to call because we have already type checked over here, because if the animal is of the dog, then it can go and wag a tail. This is safe to call, otherwise the application may crash as well over here. And as well as for the cat, it is also safe to call over here, safe to call a climb tree, because we know that it's the type is of the cat as well. And for the cow as well, this is safe to call because we know that we have already type checked over here. And if I go and run all of this, we should not get any of the error, all should pass over here, right? So I hope you got the idea about the polymorphism and how we can utilize it in our application over here. So I guess that's all about the polymorphism over here. Now let us look into the abstract classes over here. An abstract class is a class that cannot be instantiated directly. It serves as a blueprint for other classes, often defining a common behavior or properties that its subclass must implement. Abstract class can have both the abstract methods, which is a method without the implementation, and a concrete method, which is the method or a method with an implementation. Abstract keyword used to declare a class as abstract, and you can create an object of an abstract class using a new or calling the constructor. Abstract method, which means that no implementation. Method declared as abstract class in an abstract class without the body, right? So basically abstract method means that it's declared in an abstract class without the body or the curly brace. Subclasses that extends an abstract class must provide the implementation for all the inherited method unless the subclass itself is also an abstract. So I hope you got the idea about that one. And cannot be instantiated directly. You cannot also create the instance of concrete or the non-abstract subclass that extends the abstract class. So this may be quite confusing over here. Just to go through the documentation, let's go and create a practical example out of it. So I'll just go and create the abstract the dart file over here. Let's try to create the abstract class. We have to use the keyword abstract over here and then the class as well. And let us say the SHAP shape over here. And once we have the class, let's just go and create the let's create a double and calculate. We want to calculate the area over here. Let's create a method without a body, right? So this is an abstract, so we don't have to put abstract in front like in the most of the programming language. So once we have the abstract method, and if we don't define any of the body over here, then it's basically an abstract method. And let's also create the double and say the calculate. We want to calculate the parameter, right? So PRIMETER, I guess that's the spelling is correct. So we have the two abstract method over here, and also let's create one non-abstract method over here. So I'll just go and say the display over here. And this particular display, let's just go and print out a simple message over here, and we'll just go and call it this is a generic shape over here. So let's just go and add this particular method over here. So now we have our abstract class, which is a shape, and we also have a two abstract method, which is calculate area and calculate parameter. These are the abstract method, right? So we don't have to add the abstract keyword in front of the method. By default, it's already an abstract. And we also have the concrete implementation of the method, which is the non-abstract method, which has the body over here. And now let's go and create the one class. So let's see a concrete class. We will be creating a circle over here that's going to extend from the shape class, right? So let's just go and extend it from the shape, and now you'll see that we get an error over here, missing concrete implementation of the shape that calculate and then the shape dot the calculate parameter, because these two are the abstract method. So if we go and read the documentation, that it says that once we have the abstract method declared, right, without a body, subclass that extends the abstract class must provide the implementation for all the inherited abstract methods. So these are the abstract methods that we have inherited. Now we must implement that one, otherwise we have to say this is also the abstract abstract, class. And so in that way, now this is also a sub abstract class of our set class. But what we want to do is we want to just go and implement that two method over here. So let's just go and override that particular two method over here, and we'll have to make use of the override over here, and then we are going to implement our logic over here. So this is the method to calculate the area. So here we'll also go and add the, let's add the double variable and the already US radius over here, and let's just go and create the constructor for this one. So we have the circle constructor, and I'll just go and say the shorthand implementation of the our variable or the class property, which is of the radius over here. So let's just go and return from here. So we need to return a double, so we are going to return the 3.14159 I guess, multiplied by the radius. So that's how we calculate the area, multiplied by the radius into the radius as well. So this will keep us calculate the area for us. And now for this one, we will just go and return the 2 multiplied by the we have 3.14159, right? So 14159 multiplied by the radius, so that will give us the parameter itself. And now, so method body override the function, so we got some error, calculate the area. So this is going to return. Let me just go and see what went wrong. Okay, so I need to close it over here. And now let's just go and have the override, or we can also override. If you don't override, that's also perfectly fine, but if you want, you can also go and override this particular display method that we are inheriting from the shape class. We already learned about that in our previous example, right, about the inheritance. And let's just go and have one more class over here, and we'll call this one as a class, and then the rectangle, rectangle rectangle, that's going to extend from the shape itself over here. So now we have the another class with the rectangle. Now let's just go and quickly implement both of the methods, and then we have the, for the rectangle we need to have the width, right? So apply the width, and then we also have the double of the height as well. And now I can go and create the constructor for the RECTAN rectangle over here, and I'm going to provide this dot the width, the width over here, as well as this dot the height over here. Let me just go and close it over here. And once we have that, we are going to go and return it from here, calculate the area for the rectangle, the width multiplied by the height, right? And also for the calculate the parameter, we are going to return the 2 multiplied by our width plus the height, right? So let's just go and add that particular simple method over here. And now in this particular, let's just go and add the override over here, and we are going to override the display method over here. So now instead of calling our parent class, so we have the parent class display, and now in the subclass we are going to override without calling the super.display over here, and I'm going to override it and I'm going to implement my own logic. So I'll just go and say this each rectangle with the width, and then I have the width over here, and the we also have the, let's say, the height, dollar height over here. And I guess that should be the one that we are going to do for this particular rectangle class. So one class we have overridden all of the methods that we have defined in the super class, right? And in the one class, which is in the circle, we just have overridden 2 methods, and we didn't override the display method over here, right? That's perfectly fine, because we only have to override the abstract method in the parent class that is defined as the abstract method in the parent class. For the method that has been already defined or implemented, we don't have to explicitly go and override that unless you require it. But here we have explicitly overwritten that, right? And here we haven't, so that's perfectly fine. So let's try to go and create our void main method over here, and in the particular main method we are going to create the circle that's going to of the C1, I'm going to say, and which is of equals to the circle, and let's just go and define some double value, which is the 5.0 over here, and I'm going to say the another one each of the rectangle that we have, so RECTAN rectangle, which is of the R1 of the rectangle width I'm going to give it as a 4.0, and then the height I want to give it something like this 6.0 over here. And let's just go and close it over. So now we have C1 and R1, which is for the circle, and then the R1. So first of all, I'm going to go and display the C1 dot. Let me just go and execute this particular display method over here. Let me just go and run this one, and you'll see that this is a generic set, right? So that hasn't been overridden, so we are going to get it from the super or the parent class over here. But let's just go and override our R1 dot the display over here. That should go and execute our child or the subclass method that we have overridden over here. So this actually we have learned already in our previous classes as well over here. And now I guess let's just try to go and add some example over here. Like I'll go and print out something like the, let's go and print out the, let's say the hierarchy circle, or we have the area, right? So area over here, and I'm going to go and add the circle C1 dot, we have the calculate the area, right? So that is going to calculate the area, and I'm just going to say to fixed, to a string fixed, and I'm just going to point out to the decimal point of the 2 over here. That's just going to give us a 2 decimal point over here. And I'm going to do the same thing for our the circle, not the circle, or RCTANGL rectangle area. And here we are going to say this is of the R1, and that should be fine. Calculate the area for the R1 as well. So this is the calculate the rectangle, RCTANGL rectangle. Right, so let me just go and make it a little bit. So this is the circle area, and this is the rectangle area. So we are good to go. So let's just go and do the same thing. We have the 2, which is of the circle. I guess now we have to calculate the parameter. So this is of the rectangle parameter over here, and this is also the parameter. So now we have the circle parameter, and then we have the rectangle parameter. So this is of the C1 actually. So C1 dot calculate parameter, and then we have the R1 dot the calculate parameter. So one is for the circle and one is for the rectangle. So these are the printout that we have over here. And also we can actually go and type this one as the shape, right? So that's also perfectly fine. This is also a shape, right? So if I go and run, that should be also perfectly fine, because the circle is a shape as well as the rectangle is a shape as well. So that's perfectly fine. And let's try to go and create one more simple example. I'm just going to create a list of the shape over here, right? So I just want to show you how we can actually do some crazy stuff over here. So shape over here, and this is a, it will take a list of the, let's say a circle. We have the list circle, and we also have the rectangle over here, right? So not the circle, so it should be of the circle was C1, and also the R1. So we have added 2. Now it contains, the shape contains the list of the shape, right? So because the C1 is a circle, circle is the shape, as well as the R1 is a rectangle, and rectangle each are shape. So that's why we are able to type over here the list of the shape. The type is of the shape, and if you try to provide something else over here, it's going to give you an error over there. So if I go and say I have the class animal over here, right? So animal animal over here, animal animal, and if I try to go and add that or create the, let's say the animal, which is of the A1 of the animal, so ANI animal over here, and if I try to go and add that over here, that will give me an error because that is not accepted, because the list, the list of the type is of the shape for this particular list over here. That's why we cannot accept that. Now if I go and look through it, so let's say if I want to go and say for in loop over here, so let's go and implement the for in loop. Collection is of the shape that we have over here, and this is of, let's say the we have the S over here. So where S in the shape over here, I can just go and say S dot the, now I can actually go and execute the methods over here. So let's just go and add the display method. I can just go and execute that, and also I can do the same thing over here as well. So I can just go and copy this, some crazy stuff that we can actually do over here because of the type, right? It's a relationship that we are actually going to make it. So this will be of the area, right? sorry, one is the area and one is the parameter over here. So let's just go and paste it over here. So one should be of the area and one just the generic one is the parameter and one is the area. So I'll just go and say this is not the C1, this is of the S that we are providing, and this is also of the S because that's what we have over here. Now if I go and run this one, so let's try to go and run this one. So let's just go and run this one over here, right? So that's also working perfectly fine over here. Let me just go and comment out this one. So let me just go and comment out this one. Okay, so I'm going to get that particular error. So let me just go and comment this one, and now let's try to run over here. So now this is a generic shape which is coming from the STD display, and then we have the area calculation, parameter calculation, and this is a rectangle with a width, right, an area, and then again the parameter calculation. So all of those, it's looping through the C1 and R1 and looping through it and executing the methods that we have defined on that. So I hope you got some basic idea about the abstraction. So just go and read the documentation and follow the official documentation and try to practice, and you will get the more clear idea about it. So make sure to practice and learn from it. And before ending it, I want to show you one thing, which is that you cannot create an instance of the class, right, abstract class. So let's try to go and do that one. Now I'll just go and say the set that we have, which is of the S1, which is of the set, and let me try to go and instantiate that particular, and you will get an abstract class cannot be instantiated over here. So that's what we have done. We don't have to use a new keyword in the newer version of the Dart, right? But if you try to instantiate that, it's going to give you an error, right? And I hope we have covered all of the topic that we have discussed over here. And if you want to learn more, make sure to go and check out the official documentation. Let us look into the interface over here. At interface, we have an implicit, explicit interface as well as the pure interface over here. So let us look into the Dart. The concept of an interface has evolved. Historically, every class implicitly defined an interface. So in Dart, every class implicitly defines an interface. So whenever you create a class, with the Dart 3.0, the language introduced the explicit class modifier, which includes the interface and abstract interface to provide more explicit control over how class can be used as an interface and how their contract are enforced. And in the implicit interface, every class in a Dart automatically defines an interface with the same name containing all its public member, methods, getters, setters, instance variable. When a class implements another class, it's essentially agreeing to implement all the public members of that particular class's implicit interface. This is distinct from extend, where a class inherits and implements. With implements keyword, you only inherit the contract, right, the method signature, not the implementation, and you must provide your own. And then we have the interface modifier. To define an interface, we use the interface modifier library outside of the interface on defining library. The interface can implement the interface but not extend it, right? So once you define that, it can only be implemented but cannot be extended like an abstract class. It can't be inherited, it can be implemented as well as it can be constructed. So basically the difference with the abstract class over here with the interface modifier is that it can't be inherited, but in the abstract class we can inherit that and it can be implemented, right, and it can be constructed, whereas in the abstract class we cannot go and construct the class, right? So the next one is the abstract interface modifier, which is in the Dart 3.0 and above. You can see that the abstract interface combined defines a pure interface. So in Dart, if we are talking about the pure interface, we need to have an abstract interface. A class marked with the abstract interface cannot be instantiated directly like an abstract class. A class that implements an abstract interface class must provide the concrete implementation for all its members, both the abstract and concrete member defined in the abstract interface class. This is the closest Dart come from the traditional interface concept found in the language like Java, where the interface defines as the contract without providing any implementation. So if you are coming from the Java, like programming language, then in the Dart, abstract interface is the quite closer to that particular concept. So let's go and create our interface over here. I have already created one file, and let's go and start creating our example over here to better understand what we have read over here, right? So this is just the documentation for you to understand, and you can go and play around with this particular concept in this particular file. Let's create the first one as a class over here. So our traditional class with, I'll just go and say that, let's say implicit logger, IMP LICI, I think the implicit logger, right? And with this particular implicit logger, let's have the void method over here, and let's say the log the message over here, right? So we have the log message, and we are going to take some the parameter, let's say a message over here, and now we are going to print that over here. And let's go and say I'm going to say that this is the implicit logger, and I'll just go and paste it over here, and with that I'm going to go and log the message that we are getting, right? Let's just go and close it, and I guess that should be fine. And let's go down over here. I'll just go and say the string get the let's say a version over here. I'll add the getter that's going to return something like 1.0 over here. So let's just go and have that one over here. Now once we have this traditional class, which is also, and if you go and take a look, it's in the implicit, so implicit, right? So implicit interface over here. By default, every class in Dart is an implicit interface. So let's just go and implement this one. So let's have the class over here, and then the console, let's say the logger over here, that's going to implement from our implicit logger, right? And once I have that, you need to see that missing all the concrete implementation, right? So we have to go and override everything. So whether that's this one particular class or the getter, we have to go and implement all of those over here, right? So without that we can't continue, because it's going to give us an error. So once you go and implement any class, right, by default it allows you to implement any class. With the implement keyword, we are not using the extend keyword over here. We are not extending or inheriting from this particular class, because if you go and inherit, you don't have to go and override, right? So we already learned that one. But once you implement, then everything, that whether it's abstract or whether it's the concrete implementation of this method, right, or the properties, we must go and override it, right? So we must go and override and provide our own implementation over here. So let's just go and have our own implementation for this one, and I'm going to say that this is the console logger over here, and with this particular console logger I'm going to add my own let's say the date and time .now, and also the $message over here. So we are going to provide that over here. And now let's just go and close this one, and from the getter I'm going to implement, or I'm going to return the different version. Let's say I'm going to return the 1.1 from here. So we got two different, right? So one, this is the class, normal class, then we are implementing it in the another class. So once we implement, we have to go and override all of the public member that we have added over here. Let me add the comment over here. So let's just go and say this is an implicit interface over here. And if you go back over here in the implicit interface, every class in Dart automatically defines as the interface with the same name, right, containing all the public members, method, getters, setters, instance variable. So when a class implements another class, it essentially agreeing to implement all the public members. So if we have the private over here, so let's just go and have something like the void, and let's say display over here, and if I have that, this is in the same library, right? So but if we have the another one, so if I go and copy this from here, if I go to the main, which is of the different library, right? So in the Dart, it's defining on the file, right? So here I'm going to implement that particular, let's just go and import this one over here, and now you'll see that it's not giving us an error for the private method that we have defined over here, but in the same library obviously it will give you an error that you must go and implement that one as well over here in this way, right? But outside of that particular library, you can see that it doesn't give you an error. So that's the difference over here. So let's just go and remove this one from here. We are not going to use it, so let's just go and remove it from here as well. And next, let's go and create the another one which will be of the interface over here. So let's make use of the interface keyword over here, interface class, and let's have the vehicle over here, and let's go and create the one method which will of the void, and then the move forward or the move forward over here. And let's just go, okay, so let's just go and take some parameter over here, and I'll just go and say int, and then the rs meters over here, and maybe we'll just go and remove this one, and let's have the okay, so this we need to have, if you take a look over here, move forward must have a method, but the vehicle isn't, it's a abstract. Since this is not an abstract over here, we can't go and create the abstract method over here, so we must go and have our implementation or default implementation over here. So something like let's say default, so default default, so let's say move forward over here, so default move forward. So you can see that if this is not an interface, we can't go and have the interface method as well over here. Sorry, if this is not the abstract class, then we can't go and have the abstract method over here in the interface. In the interface, everything should be a concrete implementation rather than a abstract implementation, right? So let's just go and have one method over here. Let's go down over here, and now if I go and have the class, let's say the car over here, and in the car I'm going to implement the vehicle over here. So let's just go and implement that, and now I have to go and implement or override the missing. Okay, so let's just go and override our move forward over here, and here I can go and have my own implementation. So let's just go and create that, and I'm just going to say the car is moving forward. So let's say car is moving the forward over here for r, we are the forward over here, and I can just go and say the meter that we have defined over here, right? So let's just go and close that, and also I can go and have my own methods over here. Let's say void accelerate over here, and with that particular accelerate, I'm going to take in the int as well as the value over here, and I'm going to print that one over here. So let's just go and print that, print the car is accelerating, and we can just go and say the, let's just go and say the current speed over here, and then define the value that we are passing. So now we can implement this particular interface, but if you go and take a look in the documentation over here, it the interface modifier, to define an interface, use an interface modifier. Library outside of the interface on defining library can implement the interface but not extend it. So if I go over here, and if I go and say the extend, so ext and the ends extends, so I can extend it. But if I go outside of this one, right, outside of the current package, if I go to the another package over here, and if I go and import that, okay, so it's not possible to import, I guess. Let's go and see what is over here. Vehicle can't be extended outside of the library. So yeah, that's correct, right? So it can't be extended. So the class vehicle can't be extended outside of the library because it's an interface over here. So if I go and I need to go and implement not the extend, right? imp implement over implements implements over here. So I need to go and implement outside of the library, but in the same library I can go and extend that also, right? So that's the difference over here. Basically, once you have the interface, we are going to make using the outside of that particular library, then we must go and implement. We can't go and extend that. So once we have the implementation over here, let's just go and implement it over here. And I guess let me just go and duplicate this particular class over here. Let me just to show you that we can extend the let's say this is the bike that's going to extend extends from the vehicle over here. This is allowed, right? This is allowed in the bike over here, and this is of the bike. This is allowed in the same library over here, but it's not allowed outside, or it's not allowed in the another library, basically the another file in your project over there. So I hope you got the idea what we are trying to do over here. And also if you go back over here, it can't be inherited it can be implemented, it can be constructed as well. So if I go back over here, if I try to go and implement this particular vehicle over here, so let's just go and I'm going to say the vehicle, which will be of equal to the v1 as the vehicle over here. You can see that we can go and instantiate that particular interface that we have defined over here. So that's not the use case that we basically want to have, because once we have the interface, we also don't want to go and have object created out of it, right? So we don't want to go and instantiate. So this does not solve our problem basically, right? If we have just the if we just have the interface class, but that doesn't that allows us to go and instantiate, that doesn't solve most of our use cases, right? So it can be implemented, right? So we can make use of implemented keyword, that's perfectly fine, but we also don't want to go and get constructed, or we also don't want to go and instantiate or create an object of our interface. So the next example we are going to take is the pure interface in the Dart. We have talked about the abstract interface. So let's just go over here and let's create the abstract interface over here. Abstract interface, interface, the class over here. This is the abstract interface class, and I'm going to call this one as the payment, maybe a payment processor. I guess that should be fine. And now I can just go and have the void, let's say the process the payment over here, right? And we are going to take some parameter like this. So let's say a double over here, and then the amount that we're going to take in, right? And let's just go and create the another one as well. The let's have the boolean type over here, validate. Let's just go and validate the card over here. So let's just go and validate the card, and we are going to pass in the card number over here. And this is also the abstract method. Now you can see that we are able to create the abstract method, which was not allowed in the interface itself, right? And now let's go and create the this variable for the getter, get the processor, I guess the process SOR name over here. So we want to get the processor name as well, right? So we got the 3 abstracts over here, as well as if you want, you can go and have the void something like the log over here, and I'm going to, sorry, not the capital, should be of the void log over here. And with this particular log, I can just go and print the log object over here. So I am a logger over here. So obviously you can go and have the concrete implementation in this particular abstract interface class, or the pure interface in the Dart, that doesn't matter. But basically once we have the abstract interface class or the pure interface in the Dart, we basically just have the abstract method and abstract properties over here, not the concrete implementation, right? So, but sometimes you may have use cases, but usually we don't have that particular use case to have a concrete implementation in our pure interface over here. So once we have this particular pure interface over here, what we can do is we can just go and create the class over here, and let's say the credit, let's say credit card processor over here. That's going to implement from our payment processor over here, right? So let's just go and payment processor. Let's just go and implement it, and we need to go and override the for missing over here, right? And now if you take a look, the void log is also available over here, because we need to, once we have created that particular in our pure interface, we must go and override it, right? Otherwise it's not going to work. So I can just go and have my own implementation over here, print I'm just going to say the credit card processor logger, right? So this is, I'm going to log it over here, I'm logging over here, right? So let's just go and close it over here. And then the payment processing, so let's just go and have the print, and let me just go and log it over here as well. And let's go down, let's just go and remove this one from here, and I'm going to go and return from here. This is okay, processor name. So let's just go and return from here first of all, which is of the validate the card. So I just want to go and add a simple validation. So this is going to return as the card number over here. So let's just go and add the card number over here. So that's going to return us, right? And I guess I need to just go and fix the name over here as well. Okay, and then finally get the processor name. So I'm just going to show what is the processor name. This is a string, so I'll just go and return maybe a strip over here. So this is the how we are going to implement the pure interface over here. So this is a pure interface in the Dart. So we have to go and implement, and every method, that public method that we have defined over here, we must go and override it, whether it's the abstract or whether it's a concrete implementation. And let me also create one more class over here that's going to implement the payment processor over here. Let's create the class over here and the PayPal processor, PayPal, right? The processor over here, and that's going to go and implement, right? So MPL implements from our payment processor over here. Let's just go and implement that. And now I need to go and implement all of those for as well over here. So maybe I'll just go and copy this one, so I don't have to go and rewrite everything. Let's just go and copy that and paste it over here, and this will be of the PayPal over here. That should be good enough, and that should be good, right? So we have the two class implemented our payment processor, which is the pure interface over here. Now let us go and create the void main method over here, and in this particular void main method, I'm going to go and say the payment processor P1, which will be of equals to the payment processor, and let's try to instantiate. So you can't go and instantiate because this is an abstract class, right? And if you go and take a look over here, this is our pure interface that we have defined over here. So this is the abstract interface class, which act as a pure interface for us, which can't be instantiated. This is what we actually want over here, right? So let's just go and comment out this one over here, and we can go and say our credit card payment processor. So I'll just go and C1, which will be of the equal to the credit card processor, and also we have the PayPal processor that is of equal to the PayPal processor over here. So let's just go and create the instance of that. So I'll just go and say the P1 as well over here. So we can go and instantiate our class that is implementing our payment processor. And now I can just go and call the C1 dot, let's go and say the process the payment and provide some amount over here, as well as the P1 dot process the payment over here and provide some amount as well over here. So that should be good enough over here. And also we can do something like the let's say we have the list, right? So let's create the list over here, and the type will be of the payment processor over here. Let's try to create some polymorphism example as well with our abstract interface over here. And this will be of the P2, I guess, and which will be have a list, and here we can add the C1 as well as the P1 over here. And then let's just go and close. Okay, so this is the C1, and element creditor can't be inside the list of the payment processor. Let's take a look what went wrong over here. C1, which is a credit card processor, and PayPal. Okay, so this is a PayPal processor. Sorry for that. It should be of the payment processor, which is that should be good enough. And now I can just go and make use of the for in loop over here, element in our P2 over here, and I can just go and say the E over here for the element, and I can just go and say the P dot not the P dot, it should be E dot the process the payment or validate the card over here 10.100. Okay, so let's just go and have that decimal point over here. That should be good enough, right? And also we can just go and say the E dot the validate, right? So not the C, it should be of the E dot the validate the card as well, and then we can just provide the card number over here, right? So let's just go and have that over here. So I hope you got the idea. Basically, once we are using in the actual project, we will be making use of the pure interface or the abstract interface class to create our interface, which fulfills most of our requirement. Like we can't go and we can go and inherit, as well as we can't go and we can implement it, sorry, but we can't go and construct that particular interface. That is what we require, as well as we can go and we are not going to inherit, but we are going to implement it, right? So if I try to go and extend it, that's going to give me an error basically in our different file over here. And that's if you are going to extend it from the same package, that it can be allowed, right? So that is not the requirement. Once we create the interface, it will be a separate file or the separate library or the separate package. But once we create a real project, we will have a multiple files, and we have a single responsibility file, right? Every file has its own responsibility over here. So I guess that's all for the interface over here. And try to go and read out this particular documentation and also the official documentation to learn more about the interfaces in the Dart. Now let us look into the mixins over here. And if you take a look over here, mixins in the Dart are a way of reusing a code in a multiple class hierarchies. They provide a mechanism to add functionality to the class without using a traditional inheritance. A mixin is essentially a class that can be mixed in with other classes to extend their capabilities. In the simple words, we can basically say a mixin is essentially a class that can be mixed in with other classes to extend their capabilities without making use of a traditional inheritance. So the mixin keyword over here used to define a mixin. A mixin can be instantiated. A mixin cannot be instantiated on its own and cannot have a constructor. It can contain a method, getters, setters, and instance variables. This basically means that even though it's like a class, but we can't have a constructor and it can't be instantiated, which means basically we cannot create a new instance of a mixin, or we cannot create an object out of the mixins over here. Reusing code across the class hierarchies over here. Mixins are particularly useful when you want to share a set of behaviors among classes that don't share a common superclass, or when you want to avoid a complexities of deep inheritance hierarchies. So we'll see this in practically. So here in definition it may be quite a bit complex to understand, but once we do it practically it will be much more easier to understand. So with keyword used to apply a mixin to a class. So with keyword is used to apply a mixin to a class. A class can with multiple mixins. So basically a class can use a with to add a multiple mixins to it. The mixins member are added to a class as if they were declared directly in the classes. So if you define any properties or the behavior in the mixin, the class whichever is going to mix in with that particular mixin, that can easily, or it can use that particular properties or the behavior as if it was directly declared in that particular class. We'll see that in practically as well. And if you take a look, there are some restrictions and best practices for the mixin as well. The no constructor, mixin cannot declare constructor. No extend clause, a mixin cannot extend another class. It can however implement other classes interface or on other classes. This is actually a keyword, on other classes, to restrict which class can actually use it. So if you want to restrict the mixin to use it with a specific class, you can do that. On keyword, a mixin can specify that it can only be used on classes that extends or implement a certain type. So as I mentioned earlier, this is done using a on keyword. So if you take an example, mixin logger on animal, which basically means that only an animal class can go and can use that mixin logger. Other matters, if a multiple mixin or the class itself define a member with the same name, the rightmost mixin or the class itself in with clause data precedence. Basically it means that if you have a multiple mixins and that particular mixin has the same property or the behavior, then the rightmost clause takes the most precedence. Abstract method, mixin can define an abstract method as well, which must be then implemented by the class that use that particular mixin. Right? We can also define an abstract method. So let us go and create a file, and let's have some practical example over here. So first of all, we are going to create one mixin. So we have to use a mixin keyword over here, and let's say we are in the login mixin over here, and let's create a one method over here, void log. That's going to take a string parameter, and we are going to say the message, message over here. And let's try to go and log, or let's just simply go and print out this one over here. So I'll just go and say the og log over here, and we are going to say let's log it with the date and time stamp over here. We are going to provide the date and time stamp, and then we are going to say basically the message over here, right? So we have to also print out the message that we are going to print. Okay, so I guess where is the message? So this is the message, so I have to make a $sign and then access that particular message over here. So this is one, and let's create another one as well. So the mixin, and this will be swimmer. So one is a logger, one is a swimmer. So let's have one void method which is to y and swim over here, and I'm going to say that it's going to print out the y the swimming. I guess swimming gracefully is a good message, so let's just go and add that one over here, and we'll create another mixin as well. So let's create the FL flyer, so FLY flyer, and I'm going to use that on the ANI-ML animal. So ANI-ML animal. Okay, so it's not from the abstract. We are not going to import that on animal class. So currently we don't have, but we are going to create that soon. So for that, I'm going to create a class as well over here, and class will be of the animal over here, and with that animal I'm going to have a string name and also the int of the age, right? So we have the int age, and we have the animal constructor over here. Let's use the shorthand this dot the name, the name over here, and then the this dot the age over here. So that's the two parameters that we're going to use. And let's have some method over here. So void if, so animal cannot be voice, void void, and it's going to have a method to if over here, and I'm going to just go and print out that one, and I'm going to say the dollar name, actually name is eating over here. That's what we want to do over here. Okay, so we have that, and now we have the flyer over here. That's going to mix in flyer on animal class. So we are basically saying that this mixin flyer is only available for the animal class. Okay, and then now what we are going to do is let's try to go and have a animal flyer. So I'm going to say the void fly. So right, I need to have a fly method over here, and it's going to print out something over here, and I'm going to say that the name, right, so name is actually flying over here, flying hat, right? So that's what we have. Now we have a couple of mixing, 1 2 3 mixing over here, and then one class over here. So now next step will be to have one more class which will be of the dog, right? So dog, and this is going to extend, it's going to extend from the animal, right? So once it's extending, once it's going to extend, then we have to go and actually implement. If I go over here, so let's go and implement, doesn't have the 0 implement. Okay, so here I need to have a constructor actually. So I need to have the doc over here and create the constructor for this one, and I also need to go and call the super right over here as well. So two optional parameter I need to two positional parameter that I need to pass in. So I'm going to take that one as well over here. So I need to go and take that one over here, or I'm going to take this one directly over here. So this dot the, okay, so currently we don't have this, so I need to say I need to add the animals, which is of the string, and then the animal, string the name, and then the int of the age, and I need to pass that the name, and I need to pass that particular age as well over here. Let's just go and pass that. So that should be good enough. And now if I want to add the mixin over here, so how can I add the mixin is I need to make use of the with keyword, and with I can just go and say the logging, right? So I have a login mix, add it over here, and now I can also add this particular swimmer mixin, and also I can add my flyer mixin as well. So now you can see I am inheriting from the animal or parent class over here, as well as I'm using a with mixing, so I can mix in with the multiple mixing over here. If you want to extend the multiple classes, that's not possible here because Dart doesn't allow you to extend multiple class over here. But what we can do is for the multi-inheritance, we can actually go and make use of the mixing in the Dart. So in this way we can actually fulfill the multi-inheritance over here as well, because now we are actually going to make use of the mixing logger, swimmer, and flyer as well over here. And with this actually, so let's just go and override at the override. I'm going to override the, I guess I have a swim. right? So this is a duck, so it can actually swim, right? So I'll just go, and instead of calling this super, let's just go and I'm going to log it, log log. So why I can make use of the log is this is defined here, right? So that is defined here, so I can use as if the log was the method of this particular duck class, because we have mixing with that particular login. So you can see the log method is we can access as if the method is the method of the duck class itself, right? So here I'm going to pass in some message over here. I'm going to pass the dollar name that I have. Dollar name each bring us the ACI special, let's see, dot swim over here, right? And that's what I'm trying to see over here, right? And let's also go and log something or print something over here, dollar the name over here, and I'm going to say each. Okay, so let's just go and copy this one over here, right? So let's just go and add it over here as well. So just for the sake to see what's going on actually over here, right? And next what I can do is I'm going to have another class over here as well, that will be of the fish over here, and it's going to extend from the animal, right? Extends from the animal, and I'm going to use a width, and I'm going to use any in this particular can only swim, right? I'm going to just extend with one. I'm just going to add a quick fix, create a constructor, and I guess that should be fine. Or okay, so let's just go and use a shorthand as well over here. Now this particular fish has extends the animal as well as it's mixing with the swimmer, or the mixing over here. And the one thing that we need to do is remember is that we cannot go and have a mixing first and then extend that, right? Basically the rule is that we need to have the extend the class first and then use a mixing at the end. First is going to be our inheritance, and then we are going to use our mixing over here. So make sure to remember that one over here. Next, let's just go and add a simple method over here, which is of the void, and let's say blow the bubbles, right? So blow the bubbles over here. And I'm going to just go and print out a simple message over here, $name, and each blowing the blowing the bubbles over here. So that's what we have. And next we can also have one more class over here, right? And with this particular class, and I can just go and create maybe a bird over here, bird class, and that's going to extend from the animal as well. And I'm going to use the width and the flyer over here, right? And now I can just go and quick fix the constructor and void over here with this let's say chirp over here, and I'm going to print out a simple message, and let's say a name over here, and is chirping, the bird is chirping. Okay, so let's just go and have that over here. So if you take a look over here, we have this animal class, and we have the logger mixing, swimmer mixing, as well as the flyer mixing over here. And this flyer mixing is on animal. Basically, whoever extends this particular the animal, that's basically can make use of the mixing. So only the class. Let's just try to go and make use of this one over here. So let's say I have something like a class over here, and I have the class of the dog, and then I'm going to use the mixing the flyer over here. You can see that the let's just go and see if what is the quick fix. Created 3 missing override. Okay, right? So I have the age, name, and then the it that is coming from the flyer. So flyer can't be mixed into an object because object doesn't implement the animal. So this is what I'm trying to say over here. This flyer is only made for the animal, which basically means this mixing can be only mixed with the animal over here, right? So that is what we are trying to say. If any other class try to mix in with this particular flyer, then it's not going to work. So we can put some restriction over there, like which class can go and mix in with this particular mixing, right? So which class can use this particular mixing. That is what we are actually trying to say over here. So that is some kind of a restriction we can actually put over here. So now let's go and create, and let's try to execute all of our methods. I'll just go and void the main over here, and now let's try to have our duck class, which is of the d1, which will be of the duck over here. Name, I'll just go and say the DONL, the Donald, and then the age, let's say of the 4 over here, and then let's just go and close it over here. And I can just say d1 dot it, right? So this is actually coming from where? So from animal. So in IML, the it is actually coming from the animal. So we have this one in the animal. So if you see that this particular mixing doesn't have that particular function, as well as here we don't have that particular method, that is coming from the parent class, right, or the superclass of the animal over here. And similarly, what we can do is dot the I guess we have something over here which is of the swim, right? So this is coming from where, right? So this is overridden. I think this is the OVRIDE, and overridden in the duck, right? And also I can, let's just go and say the d1 dot, I can make use of the log, right? This is, I can make use of the log message as well. That's because this particular is mixed with the mixing, is making use of the logging, swim, and as well as the fly. So flyer can fly. So if you go and take a look over here, you should have that particular fly as well, right? Duck can fly as well, eat, swim, fly. That's what we have set up. And if you go back to the doc, and let's try to add the one more method over here, void, and if I go and say quiet, QUACK, right? So doc does the quiet over here, and let's try to go and print over here, and I'm going to say that the name each, sorry, not the at, it should be at the dollar, name each, QUACK, quiet, right? Let's just go and duplicate this, and I want to log this, so I can just go and log this one as well. So now if I go and say that the d1 dot white, right? So if I go and run this one, so here you get that it's logging, right? Donald is eating, this is logging, it's doing a special dot swim, this is a log again, and this is quieting, and then flying high. That's all that we have over here. So this particular is extending from animal, but as well as it's making use of other functionality that we can attach to this particular class, as if that it was its own functionality, right? In this way we can more easily extend the multiple mixings over here. With keyword we can use some multiple mixings, right? You write a specific functionality and create the mixing, and you can just go and use it with, or you can mix in with any other classes more easily, instead of going and depending only on the inheritance over here. Next, let's try to go and create our fish over here. So fish, let's say f1, which is equals to the fish, and the fish name, I'll just say Nemo, and then the, okay, so it should be of the NEMO, and then the age, I'll just go and say the 2 over here. Let's just go and close this one, and f1, I can just go and have a method to eat. So fish can eat, as well as the f1 dot, it can swim, right? And then we have the f1 dot, we also have the blow the bubbles over here, right? So this is a SPCRFI specific to the fish only, right? It doesn't, you can't have that in the doc, right? So let's just go and run that. So this is swimming, Nemo is blowing the bubbles, Donald is okay, so I guess is eating, f1 that eating, so let's go and say, okay, so eating is coming from here, right? So name eating. So here I guess we are not passing that, so it's taking actually the super one. I guess we, okay, so here is the one actually. So this should not be the one actually. That's my mistake over here. And this is also the int, and then I need to actually call this one from the super. So super name and then the age. That's what we have to do. That's why we got and Donald over there. So now we have the Nemo is eating, swimming gracefully, and Nemo is blowing the bubbles. That's what we have to do. So same thing, it will apply to our this particular class, because we are using a super. So it's, we have already defined that particular name in the super. That's why it's taking use only of the Donald there. So let's just go and have one more, which is of the bird as well, right? So b1, which is equals to the bird, and let's give a name as ROBI and Robin, and then the age of the 5, and let's just close it. So I'm going to say the b1 dot, I can go and say the bird can eat as well, right? And then the b1 dot can fly as well, and also the b1 dot the chip as well over here. So now I can just go and close it over here. Let's try to run this one. So now we got that one as well. So I guess everything's working fine over here. And let's go back to the readme over here, and then we will take a look into something like the let's go and see what we want to do. Take some example from here. Let's take a look into this particular, the rightmost mixin. Take the most the precedence over here, right? So let's try to take that one example, and we have this particular swimmer, and let's also create one more. Let's see a mixing of the, I'll just go and say the mixer of the working over here, and here I'll go and have the same one, which is of the log, right? So let's just go and have the log message, and here I'm going to log this particular, I'll provide this one over here, login with this one over here, provide the class name over here. I guess that will be much more better, and that should be fine. So now we have this mixing as well, and let's go to our bird over here, and okay, so I guess the bird doesn't have that, so let's just go and add in the another mixing as the log over here. So mixing lo logging as well as we have the walking, right? So walking. So let's have these two mixing over here. So we want to see that this one takes the precedence over here, right? So that will have more priority over here. Let's try to go and say the b1 dot the log, right? And this log exists in both of the logging and as well as the walking. So let's try to pass in the message, I am walking, right? So let's just go and run this one, and let's try to see. So here you will see that the log walking, this is what is taking. So this is what it's talking about, right? So if a multiple mixin or the class itself define a member with the same name, the rightmost mixin or the class itself in the with clause take the precedence. So that is what it's trying to do with it. So we have the two mixin actually, and in the two mixin we have two different mixin, but we have the same method defined over here, which is a log and then the log as well. But here once we make use of the mixin in our bird class, we have the logging as well as the walking, but the rightmost will always take a precedence. So if I switch this one over here, right? So let me just go and switch this one to over here, and if I go and run this one, you will see that it's going to this one, right? So that is taking the precedence over here. So I guess we already saw all of the examples that is defined over here. Make sure to go and read this one, and also read the official documentation, and try to practice in your, the more you practice, the more you get the knowledge. So I hope we covered most of the topic that we have discussed over here. And let's try to go back, and if I go and try to construct this, let's say we have the logging, and let's say the L1, which will be of the logging, right? If I try to go and construct that, right, it will give me an error because it cannot be constructed over here. And similarly, if I go and add the flyer fly flyer the constructor over here. If I try to go and add a constructor, Mixin can't declare a constructor. So this is what I'm trying to say in the documentation over here. So I hope you got the idea, and I guess that's all for the Mixin over here. Let us look into the static members over here, and this will be the final lesson for our module 6 over here. If we take a look over here, static members belongs to a class itself instead of a specific object. What does the object mean over here? Once we create an instance of any class, then it's going to create an object over there. But the static members belongs to a class itself. It's not belonging to any specific object, right? Later we'll see that practically. They are useful when data or behaviors should be shared across all objects of a class, or when you want to create a utility method that can be called without creating an object. So without creating an object, if you want to call some method or a utility method, then we can make use of this static member over here. So let's go and see the static variables declared using a static keyword inside a class. So if you declare any of the variable using a static keyword inside the class, then it becomes a static variable shared by all objects of that particular class, right? So once we create that, it is shared by all objects of that particular class. Access using a name of the class, such as you need to make use of the name of that particular class. Let's say a dog dot, and access that particular static variable. Whereas we need previously we saw how we create an object of the dog. Let's say our variable dog equals to a dog and pass in the constructor and so on. And then after that we used to say a variable dog dot using that particular. We create an object first and then we access that particular variable. But in the case of the static, we can see that we can access it using directly through the class, because it's a class belongs to a class itself. It's a static members belongs to a class itself instead of the specific object. So we basically don't have to create any of the object of that particular class to make use of this particular static variable. Otherwise, if you can remember, if we create a variable inside the class, to make use of that particular variable, we have to create an object of that particular class, and then we can access it. But in case of the static variable, we don't have to do that. We also have the static methods over here. You can say declared using a static keyword inside the class itself, called using a class name such as the class name, and then access the method. It's the same process, right? So in the previously we had to create an object, and after that we can access this particular method. But whereas in the static method we can just make use of the class, we don't have to create an object, we can directly access it, right? This is the same thing that we have defined over here. Cannot directly access instance variable or the instance method because they do not belong to any specific object, right? So it cannot directly access instance variable or the instance method because they do not belong to a specific object, any specific object. Static const over here, often used for fixed value that belongs to a class, commonly written using a static const as well. So if you want to make use of the const as well, you can make use of the static const as well. So let's just go and create some sample example over here just to show you. So let's just go and create a new file of the static member.data over here, and let's just go and create the class over here. And class, I'm going to call this one as the student over here. And in student we are going to have what we can have a name of let's say string type is of the name, and int I can have the marks over here, right? And I can just go and say I can also have the static variable over here, static type is of the string, and then the school name over here. And the school name I can just go and say let's say right future school. So let's just go and have this over here. And we also have something like a static over here, and this will be the type is of the int, and I can just go and say the total students, which will be equals to something like a default value of the 0. And now I need to create the constructor. So let's say the student, and then we need to pass in the this dot the name shorthand for creating that, as well as the this dot the marks that we have over here, right? And once we have that, and once it's being created, once the student object is created, we want to just go and say the student object and will be incremented, right? So let's say first is of the 0. If the another student is created, we just want to increase the total students by 1, right? So let's go and say 0, 1, 2, 3, and so on, right? So it will get incremented over here. And I will have some method over here that is to display our the student info over here. So we want to go and display our student info. I just want to go and print out the name over here, right? So we have a name over here, and then the name will be of the dollar sign name. And let's just go and close it over here, and let's just go and have this one over here. Okay, sorry, let's just go and duplicate this one actually. So not the name. So now we have the mark, mark over here, and this is of the marks that we have over here as well. And then another one, the last one, we are going to have the school over here. Sorry, the school. So let's see, as school over here, and then the schools, we are going to give the school name that we have defined over here as well, right? And then let's have one more method over here. So we will create a static method for this one, static, and then this will be of the void. And I'll just going to say the display not the student info, display the school info. Let's say SCHO, school info over here. So we want to go and display the school info over here, and I just want to go and print out the school name over here, and the school name will be of the school name that we have defined over here, right? And then let's just go and have the another one as well. This will be of the total student IDs, right? So let's just go and delete all of this, and the total students over here, and then total students will be of all this one, right? So let's just go and have the total students over here. So now we have one student class, and it has some the instance variable as well as the static variable, as well as the static methods, and then the normal method over here as well, right? And let's just go down over here. Let's create one more class over here, right? And then I'll just go and say the math, I'm just going to the math helper class over here. So let's say I have a static variable over here, a static const. We previously saw a static const over here, and then the double, and then I will have the pi over here. And the pi value is of the 3.1414159, I guess. So let's just go have that the static value of our pi. And also I will have a static method over here, which is of the double, and then the calculate. So let's just go and calculate the circle area. So AVARE area. So let's have that, and let's just go and okay. So here I need to go and actually pass in the double, which is of the radius radius over here. And this is it has a return type of the double, so we actually need to return something from this. So let's just go and return, which will be of the pi. The radius of the circle is the pi multiplied by the our radius into the radius as well, right? So this will give us the area of the circle. So now we have one more class, which is of the math helper. It has the static const variable, which is of the pi, and also the static the method which returns us the double, which will go and calculate the circle area for us over here. And once we have these two method or the class, let's just go and have implement the void main method over here, and let's just go and print our first step is to print our school. Let's say not okay, so this should be of the string, so school name. So let's say we want to print out the school name. So what we want to do over here is how we can, let's make use of the string interpolation. So now we have the student class, right? If you remember, what we can do is I can use the student class, and I can just go and grab the static function and then the variable, right? So static method and then the variable. So these are the static variables. You can see that this is a string type, int type, and this is of the method over there. I'll just go and grab this name, and I can just go and run this one. So that's it. Okay, so I can't see that terminal. Let's open that, and let's just go and run this one. And once you run it, you can see that we can actually access that over here, the name of this school. Previously, what we had to do is let's say we have the student STUDE and the student, let's say S1, which is of equals to the student over here, and then we have to pass this one over here, and then we had to go and actually create the instance, and then we have to use this one dot notation to access the mark whatever the variables as well as the methods is in that particular. So this is actually instance variables and method that we have. So this is the of the instance variable and then the instance method that we have, so which we can only access using the instance. So in this way we have to create the instance and then we had to make use of the s1 dot notation to access it. But in case of the static, you can see that this is a student class. We can access that static variables and then the methods directly, but you can't access the instance variable and then the method with that, right? So that is how it differs over here. So I hope you got the idea about how to use the static variables over here. And the same thing for if you want to access the total students over here. If you go and run that, you got that particular over here. But if you want to increment that, what we have to do is we need to create that particular instance over here. So student, which will of s1, and then I'll just go into the student and then the name and then the mark, let's say, of this one, and I'll just go and close this one over here. And if I just go and print out this one again, that should go and increment that over here, right? So if I go and say the s1 dot, and I will just go and let's call the display the student info over here, and this is actually a method I guess. And then let's just go and print out, or let's try to run this one, and now we increment that over here, right? So this is the incrementation over here. So I hope you are getting some idea over here, right? And I'll just go and say the static variables, right? So VARABLES variables over here, and then this is the instance. Sorry, I need to add a comment. This is of the instance variable, right? So VARIABLE variable. So these are the instance variable, right? And setting out the instance variable as well as the instance method. So s1 dot, I can access the mark, right? This is of the instance variable, and let's add the one more, which is of the instance method, right? So which we can't access directly using that particular class, right? So these are the class, these are the statics, right? So if you go and take a look in the readme, you can see that the static variable declared using the static keyword inside the class, set by all of the object in the class, accessed using the class name. And let me show you one more thing over here. So let's say if you want to go and change this student.school name over here, let's just go and say, I will just go and say this is of the test school over here, and that's going to affect everywhere, right? So it's going to change for all of our let's say since this is the student.school name has changed to the test school variable. Let's say if we are accessing it in the different class over here, or let's say our different module, and it's going to change for everywhere. It's going to change each and every places that you have used the school.name, right? So it has some similar to a single instance over here. Once you change it, it's going to change it everywhere. It doesn't matter that if you have set it out differently, right? So it's going to change in every places. And so just remember that it's going to change the globally, right? So it's going to change the value in the memory. Every place that's going to get access the student.school name now will reflect to the test school instead of what we have defined over here, the bright future school. So it's going to change everywhere. Wherever you are accessing this, it's going to be changed. But in the instance, so let's say we are creating an object and we are defining the name and then the value over here. This can have a different value, and if you create a different something like a s2 again and have a different assign a different value, it's going to have the s1 is always going to have whatever we have defined over here, and s2 is going to have a value that we have already defined, right? If I go and change this one over here, and this will be of the s2, right? And this one will be of the s2, and as well this will be of the s2 over here, and this will be of the something like, let's see, a Richard over here. I see a Richard over here. And now whether I access the s1 below this one, s2 somewhere in a different places, it doesn't matter because we have already set this one, right? Then it's going to hold the same value. The s2 is going to hold the Richard over here. S1 is always going to hold the name over here, that what we have defined. Well, let's say DAP ID David over here, it's going to hold that one. Whenever we call s1.the name, it's going to give me this, and whenever I call the s2.the name, it's going to give me this one, because that one is what I have seen. But here, if I change it over here, that's going to affect globally, right? So we need to be sure about that, and we need to use it wisely. So static variables, static methods, we need to use it wisely once we are using the OP over here, right? It has some good points as well as it has some bad points over here. So it's basically depend on your requirement. What is your requirement? So depending on that, try to use it. Don't try to overuse it, but if you use it wisely, that's perfectly fine to use these static variables and methods in your application. And we also have the const static over here. So let's say we have the double and already use radius, which will be of, let's say, 5.0 over here, and we are going to have the double over here, the OUBLE double, which will be of, let's say, area, which will be of equals to the our math helper that we have defined over here. We don't need to create an object. Dot helper math helper dot, I can access the pi as well as to calculate the area, and I can just pass in the radius. That's it, fine. So I don't need to go and create that particular instance. So here it's really useful because I don't have to go and create a instance of this math helper, because I just want to access the calculate the circle area. So right, once I pass in the radius, it's going to give me or return me back the area. That's perfectly fine over here. And now I can just go and print that particular value that we are getting back, the area. Oh, sorry, I need to add it in the area of the circle with the radius that we have passed already. US radius that we have passed will be of equals to the dollar. What we have is the radius, right? And then the area will be of the dollar area that we are grabbing over here. So let's just go and add that, as well as we have some const over there. So const, static const over here. So I have to have the value of the pi. The value of the pi that we have is of the dollar. Then we have the what we have is the math helper, right? So math helper dot, I can go and access that particular pi, right? So static const. This is a static const, which we already learned about the const in our previous module. So, and now the math helper.py is a static as well as the const. So const, basically we have already learned that in our previous modules, right? The compile time constants, right? And we have set up that one over here, right? So the static is the static as well as the const over here. So that means it's the compile time const. We cannot go and change it in once the program is running over here, which means that you cannot just go and change that particular value of the pi to something different over here, right? So this is a const variable that once you assign it, it cannot be changed, right? So this is a const time the compile time const over here. So that what we have set up over here. This is the helper method. So once you're creating some kind of the helper method, it's basically useful to have the static methods as well as the static variables over here, but try not to overuse the static member or static variables methods over here, right? So if you are going to use of the dependency injections and testing, so it will make things more complicated compared to the a normal object or the class that we create. So I hope you got the idea how we can make use of the static variables as well as the methods in our class over here. So that's all for the static members, and we will meet up in the next one.